Hello, I think this should be better now. Let me know if you guys can hear me now. Perfect. One person confirmed that they can hear me. Great. I think there were some issues with my Bluetooth headset. I just took them off and now I'm on speaker and I think this should be fine. Okay. Hello and welcome everyone to the first episode, the very first episode of You Wouldn't Type Check a Car. First thing first, I want to talk through why I named the stream what I named it. But the reason is mostly very simple. 90% of the reason is that I made this joke on Twitter and it got a bunch of likes, and the joke was about you wouldn't type check a car. I have been told that my audio is not very clear, so I'm gonna just quickly try changing the audio device and let me know if this is better. Okay, how about now? Is it better? Can you guys hear me better now? Okay, it says slightly better. I'm going to try speaking closer to the mic. Hopefully, we'll resolve these issues the next time I'm streaming. I was talking about why I named the channel what I named it. It was a hilarious joke I made on Twitter, but that's just like majority of the reason. If you don't know the context behind this joke, a while ago, I'm just gonna share my screen and show you what I'm talking about. Oops, supposed to see that. Yeah, so a while ago, the MPAA had an anti-piracy ad going around, which was "You wouldn't steal a car," which was obviously such a ridiculous way of messaging what they messaged. And in the same sort of theme, I wanted to make it sound ridiculous. This opposition I had against like type checking or formal verification, or just having these ridiculously or overly typed systems. It's a joke. I'm not against any of those things, maybe partially, but we'll get to that later. Yeah, so that's the title of the stream. You wouldn't type check a car. I also wanna talk about myself a little bit first. Introduce myself. I think some of you know me from my research, what I work on, and stuff like that. Some of you just know me as this guy on Twitter who criticizes Rust all day. And some of you just know me as Ajay. You know me personally through like your friends or via friends or your like, family members and so on. But to give you to talk about myself in the context of this stream, I am a PhD student. I work on compilers and I work on, I'm trying to get a PhD in compilers. I'm in my 6th year of PhD now. I'm in MIT, I work in Peaks department, and I've been doing compilers for a while. I was really interested in compilers when I was in undergrad. Did that for 2 years when I was working for Microsoft Research later. And then I've been doing that as a PhD student for the last 5 years now, going into my 6th year. The reason I'm sort of doing this stream is, there's multiple goals here, but the main one is a lot of people told me that they want to sort of get a sense or get an understanding of what research and a PhD life looks like. How does a typical PhD spend their day to day? I wanted to give people a glimpse of how research works in that way, because research is very different from development. I've never done development other than like the 2 months I did an internship at Amazon. But other than that, I have only done research most of my life. But I have friends. I have friends who I talk to. I have family members who are in the industry, and I get sort of like a little bit sense of how industry looks like. But not enough people talk about how academia looks like. So I wanted to give people a sense of how systems research specifically happens in academia. And one of the things all academics or all PhD students like to talk about is their research. That's the second goal of this stream. I want to just like talk about BuildIt, and which is basically my primary research topic at this point. And I will talk about just like how compiler folks approach programming languages, how compilers folks approach problems, and just like on the stream solve some problems with you, work on some projects, either directly related to my thesis or something around it. I'm not going to be playing games on the stream. I'm not going to be streaming any other videos. I'm not going to be writing even websites or any that like other kind of programming. I'm going to be focusing my stream mainly around systems research, so either compilers or something low level like networking or operating systems and so on. Things that I'm interested in, things that I do for my research. Yeah, so that's me, and that's my reason for why I'm doing this stream. And a little bit introduction about what my research is around. I said I mentioned BuildIt. The link is also on the website. This is basically my primary thesis topic right now. It's basically a system that I made 3.5 years ago now, centered around making it easier or possible even for folks to make their own programming languages without any or very little compiler's knowledge. Usually, like when we talk about programming languages, the very sort of first thing that comes up is how is this language gonna run? Like, is it gonna have a compiler? Is it gonna have an interpreter? Like what? I mean, there's obviously aspects about what does the language look like, but a daunting task that comes up is how is this gonna run? And I believe in compilers and I believe in performance, not because it's the right thing, it's because what I'm interested in. I really like sort of digging into why a language or why a program runs slow and how can we improve it and so on. So this framework basically lets you implement languages that are also focused on performance. So if you're trying to make a language for making websites, or if you're trying to make a language for making I don't know, like some sort of visualizations and stuff, this might not be the right fit for you. But if you're trying to make a language that captures the domain problems for, like, say, high performance computing on graphs or on some physics computations or some simulations of quantum simulations, blah, blah, blah. I don't know what all things people do with programming languages these days. But those things you could sort of offload it or make it with a system like BuildIt. Obviously, I'll get into more details of how BuildIt works later today, actually, because we're going to try to fix a bug that recently came up. I'll talk more about the bugs and what we're going to do later. But yeah, that's BuildIt. I have a website. I can show you the website quickly. We have a lot of information about the system, what you can do with it. Some examples, we basically have this online tool where you can just run BuildIt programs and test them out. We also have a bunch of research papers that have come out of this research. Feel free to like peruse through them if you're interested. Yeah, that's not a necessity though. And we also have some related tools as part of the same framework. So Detox is a sort of accompanying tool that lets you write debuggers along with your languages. Anyway, we'll get into the depth of this later. I just wanted to introduce BuildIt and introduce myself. All right, so I just realized I wasn't sharing the screen when I was talking about BuildIt. So here it is. This is the BuildIt website. I was just talking about it. Some examples of what you can do with it. The online tool, some publications, and the Detox company tool. All right, gonna go back to talking. The next thing I wanted to do was actually introduce how I work, introduce my setup, because I've been told that it's very weird that I work with Windows. There's obviously a story behind it, and there's a reasoning behind it. I don't do it just because. So let me talk about it. So yeah, let me start sharing my screen, and we can go through things. Okay, yeah. So I use Windows as my primary sort of development device right now. I have a Dell laptop, and yeah. So the obvious question is, why not Linux? Since most of the work that I do is high performance computing, which is targeted towards Linux or like similar operating systems, why do I use Windows? So I've used Linux a lot. Growing up, like for the last couple of years of my high school and going into undergrad, so like around 7 to 8 years, I've used Linux as sort of the only operating system on my computer, and that's where I picked up a lot of these things that I work on. Obviously, I was introduced to Linux by a friend who gave me like a shady looking disk that I installed on my computer, and I had this operating system. But again, that was a long time ago. Things have changed now. I think I understand Linux better than I understood it then. But yeah, I used Linux a lot for the whole of my undergrad, but immediately after undergrad, I worked for Microsoft. it was Microsoft Research, but we were still sort of required to use Windows on our systems at that time for whatever licensing legal reasons that they had, and we sort of I really didn't like it at that time, but I was forced to use command prompt. What I did in those 2 years was actually learn how to use Windows properly, tailor it to suit my needs, make sure that it sort of gives me what I need to do. And one of the things that I found really helpful at the time was using this tool called GNU Win32. I don't know if you guys have seen this before, but this is basically a drop-in replacement for a lot of commands that you use on Linux, like say grep or ls or find. All these kind of like GNU tools are packaged into this one sort of package that you can install on Windows, and this gives you like a lot of similar experience, at least in some ways. There's still the issues about using the slashes in the wrong direction and using executables, except that's fine. I think those things you can get used to if you use it for a couple of years. But that's how I used Windows at that time. Obviously, when I started working for Microsoft, I think WSL or Windows Subsystem for Linux was in a very infant stage. We got an early access to it towards like I think the end of my time there, and I tried using it at that time. It wasn't great. Like I think WSL used to work okay for like some of the applications, but obviously like having the drivers work properly and just like being able to use it as a Linux system did not work. So yeah, I did not use WSL as much as at the time. I mostly just used Windows. One of the good things that came out of that was I was also really actually I used Visual Studio a lot at that time, which is a great IDE, by the way. I usually don't talk about IDEs, or I don't mention or in fact speak about against IDEs sometimes. Again, personal preference, but Visual Studio is one of those IDEs that really suit me. It has a great build system, it has a great code navigation ability, and it has a really great built-in debugger. This is Visual Studio, by the way, not Visual Studio Code. I've used Visual Studio Code recently a bit, and it was not the same. Visual Studio also is a paid software, by the way, but because I was working for Microsoft, they gave us a license. Yeah, I really miss having access to Visual Studio, by the way. So if someone has like some tricks on how I can get free access to Visual Studio, please let me know about it. Yeah. After that, I started my PhD and I started using a Mac for my development. Primarily because my advisor sort of forced me to, because everyone else in the group was using one, and he was like, "You're getting a new laptop, you should get a Mac." And I did not want to like argue with him at that point, so I got a Mac. I used Mac for almost 4.5 years, and I realized like within 2 months of using it that I was using it in a very sort of non-standard way. What I was basically doing with the Mac was using it as a machine for SSHing into a Linux server in one of our groups. We have a bunch of servers that we develop, that we run experiments on. What I found myself doing all the time was I was just using Mac to like use the browser for reading stuff and things, obviously, but also just like for development, I was just SSHing into a server in the lab and working on that. That was not great. Like, I couldn't work on when I never had access to internet. I couldn't work. But the reason why I did that was Mac is very similar to Linux in that sense, but it's very subtly different. Like, yeah, it's completely POSIX compliant, I guess. It has all the similar looking tools, but it breaks in very subtle ways. Like the commands are slightly different. The API for interacting with the operating system is kind of different because they do have a POSIX API, but doesn't work completely. So sometimes you have to use their own Mac API, which is very hard to read. The documentation is really hard to read, and generally I was not able to work with Mac at all. And especially like, when I was like in the case of Windows, like I picked it up eventually, right? In Mac, that couldn't happen because I was also working on Linux and Mac at the same time. Like I still had to work with our servers to run experiments. So I was constantly switching between Mac and Linux, and that was not great. So I just eventually, 4 years later, when I got a new laptop, I was like, I'm going to get a Linux laptop. But the other thing is, I do play a bunch of games, and I obviously wanted to continue playing those games. I know Linux can support a lot of games through Wine and through a lot of like emulation stuff these days, but I really wanted to have Windows on the laptop to just like play some of the heavyweight games. So I decided to have like a dual boot system at that point, but dual boot also has issues. Like you still need to like restart, and it's a lot of time. So I thought of like trying WSL for a while before I completely give up on it and then install Linux. And now it's actually pretty good. Like if you use WSL, if you have used it recently, it actually works pretty well. So yeah, I think ever since then, it's been like what, 8 months now since I got this new laptop. I've been using WSL locally, and don't have to SSH into anything, which means I can also work when there is no network access. Doesn't happen as often, but like say I'm on a flight or something, if I'm I'm not at home, I can still work on my laptop, which is great, which is how laptops are supposed to be. But hey, I couldn't do that with my Mac. Anyway, that's a lot of talking about Windows and how I work. There's a let's get into the next part. The next part is about if there's any questions, by the way. Oh, great. There's a question that says, Mac, geez, Apple's client is the broken compiler. It is too much. Yes, this is one of the things that comes up a lot. Every single time when Xcode gets an update, it breaks the compiler. That's because Clang, if you install Clang separately on Mac, because you obviously need to, the default version is not great, it sort of remembers where the headers were when it was compiled. Every single time Xcode sort of gets an update, it moves the headers around and sort of deletes the old headers, which means your newer compiler, again, just craps out. Every single time there's an update, it breaks everything, and I'm not sure how they ship updates without testing things. But anyway, yeah, the Xcode C++ compiler is garbage, even though it's Clang. But yeah, so yeah, that's part of the reason why. And as you guys know, I mostly use C++ for my research, so it's kind of important for me. Okay, I also want to talk quickly about. Actually, you know what? Let's get into how I work. I mentioned IDEs before. I mentioned what sort of tools I use. I quickly want to get into what's my main programming system. So yeah, I don't use any IDEs. I just use I program in Vim and I compile from the terminal. That's how I do it. That's how I've been doing it for a long time. I guess like somewhere in the middle of the undergrad, my compilers professor urged me to use Vim, and I stuck on that ever since, except for like some brief period when I was using Visual Studio. But even then, I was using Vim and like the terminal to run programs on the side. I just want to quickly talk about this, the way I program. So I usually have like one terminal open with like say one or two splits of tabs. No ISP. Is that ISP or LSP? No LSP. What does LSP stand for here? If you can expand that for me. So the fact that I don't know what it stands for, oh, language server protocol. Yeah, I don't know what that is. I have never used it, and I guess I'll read about it later. I use LSP with Vim. It's nice. I should look into it, like code completion. I see. I see. Yeah, I don't use code completion a lot. I should. I think there's no particular reason I shouldn't. It's just I got used to it. And also, if you have used, I have tried to use plugins with Vim that do like better autocomplete. They're kind of heavyweight. Like it makes your Vim not as easy to work with. Like it starts to get stuck in the middle. And I tried it. Maybe the plugin I used wasn't great, and I never went back to trying it again. But thanks for the link. I will go back to it and check LSP. It seems like if it's useful, I'll integrate into my workflow. I'm never against using new tools, so I'll definitely look into LSP. Yes, I use raw control P for code completion. Yes, I do that. I've actually mapped it because I use control P. I'll talk about control P later. But anyway, let's get into how I work. So I usually have multiple split screens, multiple splits on the terminal itself, and I usually have just one Vim session open. So if I need to open a particular file, I would say like let's go here and let's open this file. Now, if I'm making some changes and I'm done with it, I use tabs, by the way. I don't use buffers like people tell me I should. I mostly just use let's say yeah, I use tabs and I have mapped keys to go around those very easily. I'll talk about that later. But here's the thing that I want to talk about first. When I'm working in Vim, and if I want to go back to running code, I don't switch to a new Windows or anything. I just hit Control Z. This actually seems very unintuitive and like a bad idea, but it's actually once you get used to it, it's actually really good. So I mean, inside Vim, I hit Control Z and I can run commands. Okay. I can run commands, and then when I'm done running those commands or whatever, I can just hit FG. FG, okay. If you guys don't know, I'm sure you guys are better programmers than I am, or developers than I am, so you must know this. But hitting Control Z sends a process in the background, and then you can run jobs to see which processes are running, and then you can hit FG to bring back the first one, or you can hit like FG. If there are multiple ones running, you can hit like FG1, FG2 based on the number that's shown here. And you can bring that process back to the foreground. This makes your workflow really easy. So like doing this makes me like go between different files at the same time, but without having to close them. And then when I run the commands, I can do this. This, by the way, if you're planning to use this, if you don't know how to use this, give it a try. But if you're planning to use this, there's a very important change you need to do to your bash RC, which is to do this. So I created this function called exit, which is by the way, in bash, I use bash. I don't use any other shells, again, for no particular reason. I just got used to bash and I never switched. But the point here is, if you are going to use this change, make sure that you change your exit function to do this. What it's essentially doing here is when you run exit, it checks if you have any jobs running, and if there are no jobs running, then it actually exits. Otherwise, it just says, hey, you have some stop jobs. Linux or Bash terminal actually has this feature built in, where if you have some jobs running and you hit exit, it will give you a warning. But if you hit exit again, it will actually exit. There are probably ways to configure that and change that. The easiest way I found was to just override the exit function I'll share this snippet if you want. I'll put it in like, by the way, I'm going to maintain like a separate resources doc for the stream. I'll post the link on the stream, the channel itself, so you guys can look at all the links that I have to share, all these small snippets that I talk about through the stream. So that's how I use Vim. I just keep it in foreground, keep it in background, do the development, go back to it, open all my projects separately. If I ever have to work on simultaneously different projects, then I use a new tab in my terminal. So if I'm like looking at some other code, if I get reminded of things, I switch to a different one. The benefit obviously of having all the tabs open in the same Vim session is that it's easier to copy stuff between those without having to use your mouse. Again, I know there are ways to make, and I actually have set it up in such a way that the clipboard is shared between the operating system and the session, the Vim session. But remember, I used to program mainly on SSH before. It's very, very finicky to make SSH work, to clipboard to be shared across SSH. So I just got used to having everything in the same Vim session, so I could just like copy things easily. I could navigate code much more easily. If you're going to use tabs, okay, let's get into Vim RC, because I've been talking about Vim a little bit. So let's talk about my Vim RC. It's very simple. I don't have any fancy things that I use. Like I have very simple configurations that I use. Part of the reason is I like to have a very consistent experience when I go to different computers. If I have like a lot of plugins installed, and if I have a lot of sort of customizations, and if I go to some other computer where I don't have those things, I have noticed that I start to sort of like rely on those things too much, and it makes it very jarring. Not a good reason. It's my compromise. I don't customize it heavily, but there are a few customizations. Obviously, you need to have tags. I'll talk about what C tags is later and how it sort of fulfills the other role of the IDE, which is navigating code, but I'll get to that later. This is, okay, so if you look at my line numbers, I use relative. So these are called hybrid line numbers, by the way. I'm sure you guys must have seen this before. It is I think a very good way to use Vim. The line number where my cursor is, the line number is shown as it is, and the other line numbers are shown related to that position. So the obvious benefit of this is if you need to go down to a particular line. So suppose I want to go to that set term GUI colors line, I can just hit 11J and it will take me there. It just tells you how far that line is. So that way it's easier. There's a comment that's saying my gear plus space Vim is plus tmux. I am going to check these things out. I have never used any other version of Vim, but I'll definitely check it out. I'm not against it entirely. tmux, I've actually sold too much into the screen ecosystem. I have actually built tools around screen to make screen more usable. So yeah, I don't think I'm going to use tmux, but yes, I know there are benefits to using tmux. I have made it work around with other things, so I think I'm gonna stick with that. But yeah, this dynamic numbering, this sort of hybrid numbering is very useful for navigation at least. But here's the thing. So what you can also do is you sometimes you need to like actually copy stuff from your Vim with your mouse. I know it's a big blasphemy, but sometimes you have to do it in very weird cases. At that point, if you try to like copy these multiple lines, you get the line number 2. So what I've done is I've made this handy S command as a mapping, which toggles those lines. So I can sort of like go back and forth. I can copy stuff, and then I can hit S again, and my line numbers will be back. Again, things that I have sort of like picked up as I've used Vim over years. These other customizations are simple. Clipboard not equals to unnamed plus. What this basically does is shares your Vim a clipboard with the operating system's clipboard, the default one. So you can copy stuff in and out. So at least I can like say if I go to this website and I copy stuff from say actually the pasting in. So like suppose I yank from here, and then I can paste things here. That's basically how it works. This actually, my pasting back into Vim is currently broken. I'm in the process of fixing that, so I couldn't demonstrate that, but yeah. So these are my tab customizations. Since I use a lot of tabs, hitting GT every time is annoying. It's just two keys. So what I've done is, J and K is obviously what you use to go up and down. So I've mapped Shift J and Shift K, or capital J and capital J to going between tabs. And that makes going between tabs very easy, especially once you're like working on a project for a while. You have sort of a mental picture of where a particular file is, and you can go back and forth very quickly. So like I know that the make file INC is like a 4th file or something like, so I can quickly go there. Yeah, that's you get used to it, and having like a quick shortcut for it is pretty good. Okay. I use tabs. Yes, I use tabs. I'm not going to debate that. That's my personal preference. But I sometimes have to work with code bases that use spaces. So I have control space mapped to 4 spaces, which comes in handy sometimes. Other things are pretty simple. I don't think I need to get into too much explanation about this, but this one I think I need to talk about. Oh, why do I have capital W and capital Q mapped to right? I used to use this Mac keyboard obviously before, and the Mac keyboard is obviously very, very bad. I had the one from 2018, the butterfly keyboard, whatever they called it. It was really bad. If you're hitting Shift : to quit, sometimes the shift doesn't like release quickly, and your W or Q also becomes capital. And I used to run into this a lot, where I used to like try to quit a file, try to save a file, and it used to put in capitals and not quit. So I just map capital W and capital Q to right and Q too. But okay, what I will talk about is this combination. So if you start using tabs like I do, you obviously open new files with TABE, just tab open. Now what happens is, if I try to open a file that already exists, that's already open, it's going to open 2 copies of it. There are ways to get around this, but my personal, sometimes I also want to open a file twice. So there's a comment that's saying capital J and capital K is the shortcut to switch tab in Vimium to. Yes, that is. I'm going to talk about Vimium next. It is Vimium is great. I mean, yeah, I'll talk about Vimium next. But yeah, it is very handy to have consistent experience across all your applications. Yeah, so what I was saying is having these files open multiple times is bad, because then you're changing the code and then one of them becomes out of sync. So what I created is this handy command called tab d, which is basically tab with deduplicate. What this essentially does is just does tab open with drop as an argument. What this would do is, if I open the same, if I open the same file again, it will just take me to that file instead of opening a new one, which is useful. But the problem is, you can only create commands with capital letters beginning, and it's annoying to type this. So I just have a mapping from this to this. So if I type this, it automatically expands to the capital version, and then I can complete in the files. This comes in very handy. I've used this tab D a lot, and yeah. These are just customizations on how I like my C++ code indented. Not very aggressive, very simple. That's how I like to deal with it. Set color column 120 is what adds this red line that you see on the screen at the 120th column. This is very good to maintain some sort of code hygiene. You don't want to have two long lines on the same column, on the same row, and that's why this red line gives you a sense of where the 120th column is, so you can stop and go to the next line if you read that. While menu, tone, GUI colors are again some simple customizations. This is what I was like trying to add recently, like make the yank and paste into stuff work properly. I'll fix that later. But yes, the last step I want to talk about Vim is I use Control P. So Control P normally does autocomplete, but what I use Control P for is this Vim plugin called Control P, which is a nice way to open files. So suppose I have, so let's see, I'll put anything before I get something up. But okay, let's say I am in my project directory, let's say I'm in the BuildIt directory, and that's how I start my Vim session. Now I open a particular file, I hit Control P, it shows me, so it's basically a fuzzy file system sort of completion, I guess. So what I can do is, like, I can say include, I don't have to type the whole thing, include blocks statement, and it will open the right file. And you can see that's how it completes. So I can say source, source and say context. So this will hop over at builder because only builder has a context file. So I can just say source, builder context, and it will show me the files. It also gives you a nice sort of like completion, like options of which one you want to open. So if you want to open a different one, you can also open a different one. But yeah, most of the times the first one it shows is pretty useful, and that's how I navigate my code. Control P is very handy. Use it. Try give it a chance if you haven't. I'll drop the links for all of these in the resource document, so you can try it out later. Okay, so that's how I navigate code. That was my customizations for my Vim. Let me check if I missed anything there. Yeah, C tags. C tags is what I should talk about next. But before I get to that, let's talk about where else do I use Vim. So, like I said, I use Vim, but I also use Vim in my terminal. So, in my batch, basically. This is enabled. This is very easy to do. If you haven't done this before, try it right now. You basically have to run this one command called set-o-vi. It basically changes your input mode for the I think it changed for the read ELF call, but in general it changes it for your batch. What this means is now you can run all your Vim commands in your shell. So when you hit escape, it goes into normal mode. You can actually do things like going between words, and you can actually like say let's find a longish command. Come on. Okay, yeah. So you could do things like you could delete word, and you can insert and type string, which is like having the Vim experience in your browser, in your terminal. And also the most important thing, because you're using the middle row to navigate between commands, you don't actually have to move your hand. I'm trying to show you guys. You don't have to move your hand between the middle row to the arrow key to go and run commands before. Yes, obviously I use Control R a lot. But sometimes you just want to run a previous command, and it's just much easier to have J and K mapped to those things. You can obviously use, and it works with all the commands. Like if I'm running, let's say, a very longish command, anyway, and don't have a longish command in my history now, it's much easier to like navigate between the command, edit parts of it, and so on and so forth. What I have also just customized that a little bit is I've mapped the control L key, which if you know, if you use bash, you know, it clears the screen to actually clear the screen because that binding doesn't do it. And I have mapped the V command to do nothing. I have a habit of hitting V a lot when I'm using Vim, and if I hit V in the middle of the command, then it opens it in a file to edit it, which is annoying. So yeah. And the rest of the okay, so there's some customizations in my bash RC. I don't think I want to talk too much about it, but I have simple things like I just want to quickly upload a file to my website in a stash directory. I just have a command for it, which runs it, sends it to the file, and gives me the URL for it. So what I can do here is like say to stash, and let's send let's say include utils tracer.h. Like I just hit this, and it takes a while sometimes because yeah, and then it gives me a link for where this file has been uploaded. What this lets me do is now, oh, sorry, yeah, now I can share files with someone quickly without having to actually SCP things manually. Can you show the set VI functionality again? Yeah, sure. So I've been told in the chat that I should, someone PM me that I should have a plugin that shows what keystrokes I'm hitting. I looked into it. I couldn't find something that was really good. Maybe I'll try again and find something that's more easier to use. But yeah, so the set OVI functionality. It's enabled by simply saying set -OVI. It stays for your current bash session, so if you log in again it will go away, or you can set it back again by I think set -o emax, because your emax one is a default one. Yeah, screen key is what I was looking into, but what it was doing was it was putting like a sorry, I was doing input overlay. That was the plugin I was using. It was actually showing an entire keyboard on the screen, and then whatever keys I'm hitting, it used to sort of like highlight those keys. Screen key, I think what you're talking about is a plugin to show it on my screen itself. Obviously, I don't want to have keys like showing up on my screen because it's distracting. But if that's something that you guys are really interested into, I can install it, and I don't mind having it on my screen during the stream. Yeah, so I can do screen key next time. Yeah, so going back to set-OVI, you can enable it, and what this essentially lets you do is use your Vim binding. So I'm hitting K right now. I'm not hitting the up arrow key. So yeah, sorry about not having that built in here, but yes, hitting J and K lets you go back and forth. Then you can use H or L to actually go back and like in the command, navigate in the command. You can use F, W, you can use E, all the regular commands that you use in Vim to sort of edit the commands that you're running. Yeah, comes in very handy. It's really useful. And the final thing where I use Vim is in the browser. Someone mentioned in the chat use Vimium. If you have not installed Vimium yet, please give it a chance. It is really good. It basically gives you all your Vim bindings in the browser. So right now I'm scrolling up and down, not by hitting the up and down arrow key or by scrolling my mouse or by dragging the bar. I'm actually just hitting J and K. You can also use things like G key, which takes you to the top of the screen, or capital G to go down. But that's not just about navigation. What you can do is you can also hit URLs by hitting the F key. So if you can see on my screen right now, all the sort of anchor links have been assigned a sort of small character. So like BuildIt, the top link has A, then D, F, J, and so on. What you can do is now you can hit those keys to actually take you to that link. So yeah, you can hit F. All the links on the website, the current page, are sort of highlighted, and then you can hit them to sort of navigate to them, which comes in really handy. Like this basically improves your experience so much. You can start using your browser without actually having to touch your mouse. Now, isn't that amazing? Like, yeah, I know a lot of people like use tabs and enter to sort of hit on links and so on, but this is so much better. It gives you so much fine-grained control over using your browser. It's really useful. Give it a try if you haven't already. You can also customize it, obviously, like the every other. Sorry, not this one. You can go to the settings, I believe. Here, yeah. You can customize it to like have like other custom, similar Vim mappings that you have, you can insert them. I don't have too many installed here, but yeah, you can add as many more as you want. Yeah, but do make sure that you disable it for, okay, best is the 2-letter shortcut for different elements in each page. Yeah, yeah. The 2-letter shortcut for different elements in each page is useful. You also can hit capital F. So normally if you hit a, oh sorry, if you hit a link, it opens it in the same tab if that's what the website is supposed to do. But if you want to open it in a new tab, which we sometimes want to do, you can hit capital F. In that case, it will open it in the new tab. Or if you have already hit F, you can hit the 2-letter combination key or the 1-letter combination key in caps, and then it will take you to the site in the new tab. Comes in very handy. What I was talking about is, oh yeah, and the other thing with it, like someone mentioned in the chat before, using capital J and capital K, you can also go between tabs very easily, which is very handy too. Like if you're like between two websites, you can move very quickly. But Vim comes with a very built-in nice feature of opening, like searching through tabs. So I can hit Shift O or capital O, and you can search for something. So like I can say Stack Overflow. It will give me either an option to open a new tab by like hitting this. In this case, it'll open a new one. Or I could say, let's say, if I type something that's already open, I can go to that tab. It's very handy. You can sort of navigate your tabs in the browser very quickly. Yeah, that's the last place where I use Vim. I've tried using a plugin before that lets me use Vim for the whole Mac operating system. It wasn't as stable. It used to work. It used to break in weird ways, so I stopped using it. But yeah, the last thing I was saying is if you ever use it on a website that has a lot of like editing text stuff, it breaks in sometimes weird ways. So like for example, if I have IDE1 open, which I use a lot to like test code out, I disable it usually for these websites just because it breaks interaction with this. But a lot of these websites already have built-in Vim bindings, so check if they don't have it. Like Overleaf, for example, has built-in Vim bindings, so I directly use that. Even Godbolt, I have it disabled on Godbolt too, but yeah. Okay, there is, oh yeah, there's one last thing maybe that I'm saying one last thing too many times. There's another plugin I have, which is, I don't remember the name of that plugin, but let's see, I can demonstrate it. Maybe I should demonstrate it. Actually, ID1, let's try it. So I have this Vim plugin, I don't remember what it's called, but if I hit Control Enter, it turns my current div into a Vim sort of into a Vim box, and I can edit it normally like that here. I'm going to hit Control Q or Control W to go back to like those changes, commit those changes, which is very nice, but it doesn't work everywhere as well. Like if your divs are custom, like for example, Godbolt has a custom like editing space, right? If you try to hit in there, the changes don't show up sometimes. Like for example, if I have this thing, and if I not Control V, Control Enter, it does. Okay, I need to highlight it first. When I hit Control Enter, oops, it does let me edit it. But like for example, I changed this to say. It doesn't show up because Compiler Explorer uses its own sort of like mechanism for like showing the text that you're typing as the input box, and that's why it doesn't work. So check it out. If it works for you, great. I'll drop the link for this plugin too. But yeah, someone said that B for bookmarks is very handy. Yes, B for bookmarks is pretty handy too. Marks also work pretty well. So when marks, if you know about them, they work pretty well too. Make me navigate in code. Okay. That's all about Vim and how my setup works. Let's get into the main part of if there are any questions, please drop them in the chat. I'll try to answer them. There's a lot more to talk about my system and how I work things, but I guess we'll do that as we sort of go through the working part of it. I quickly want to get into the main part of today's stream, which is we want to fix a bug in BuildIt. So I actually already created an issue for it. Let me pull that off. Oops. Wrong key. Yeah. So I created this bug the other day. This bug was, by the way, found by a developer, Vedant. He is in India and he has been contributing to the BuildIt project for a couple of months now. A great developer. He is contributing on implementing a loop analysis pass in BuildIt to make sort of the loop extraction more robust. And while doing that, he found this bug which shows up in BuildIt's initial extraction process, not the loop extraction process. Today we're going to fix this. So full disclosure, I have looked at this bug before I started the stream. I sort of came up with the idea of doing this on the stream after I had already looked at it, which means I already know exactly what is wrong with this, and I sort of have a sense of how to fix it. But in the future, I promise, if you're doing any fix a bug with me session, I would make sure that I don't look at the bug at all, or even like look at the code examples. That way I can sort of walk you guys through how I normally find a bug in any of the systems that I work with, especially BuildIt, and how we sort of fix it, how do we approach make sure that the solution is actually good enough for later and so on. So yeah, I am gonna do this bug fix today for you, but in the future I'll be sort of more diligent without looking at the code beforehand. So yeah, this is the bug. I'll show you guys what this does. I mentioned that the BuildIt tool has an online sort of thing where you can play with it. So let's use that. What I've already done is I've already shared sort of a code snippet here that exposes the bug. So if I hit the stage button, if I run the button, you see it produces some code, which is the good part, but it produces wrong code. Why is this code wrong? First of all, this code is syntactically wrong. There is a goto at line 16, which goes nowhere. There is no label 1. It says you should go to, if you plan to stream regularly, you should consider mic for better audio. Yes, I'm gonna consider I'm gonna get a mic if I continue doing this. I did not sort of have the time between the last sort of when I decided to start the stream and this particular first stream, so I didn't have the time to research mics. I quickly got a camera because my display doesn't have a camera. But yes, I'm going to look into options for good mics. If you have any recommendations, please drop them. And yeah, I do want to make sure that you guys can hear me well. I was hoping that my earbuds would actually work fine. I had tested them before, but for some reason they don't show up in OBS now, and it wasn't working properly. In fact, just having them plugged in was making all other mic devices not work properly too, which was just weird. But anyway, okay, so getting back to this code snippet, we have a label, a go to label 1 at 16, line number 16, which doesn't exist. But before I talk about why this issue exists and how do we fix this, I just want to quickly talk about what BuildIt does. Like this is, I'm showing you code snippets. It doesn't even make sense what I'm trying to do here. So BuildIt is a multi-stage programming framework. If you have, it's embedded in C++, so a little bit of like existing C++ knowledge is useful, but you don't need to. These ideas can be applied to any other language, your favorite language like JavaScript or even Python or maybe Rust even. But I have developed the system for C++. If you remember, I mentioned that this is a DSL system for high-performance languages, and high-performance languages that I have personally worked with are always the compilers I implemented in C++, and the folks who actually want to write these compilers have expertise in writing C++ already, because imagine someone who writes simulation for a living. They actually write a lot of C++ code, and we want them to be able to switch to our system very quickly. So what BuildIt does is it's a multi-stage framework. So let's take a simple example actually first. Let's go to the power function, which is an example I use to always explain what the system does. So in front of you, I have a power function. It takes two arguments, base and an exponent. It computes the base power exponent using repeated squaring. You must have seen this code a lot before. In fact, I think this code is borrowed from Wikipedia directly, made some changes, but yeah, it's essentially the algorithm is from Wikipedia. So if you look at if you think of it, this power function as a normal function, it takes two arguments and returns an integer. What BuildIt lets you do is specify some of those arguments and then specialize the generated code for it. If you guys can't see this, by the way, I can bump up the font a little bit. Yeah. So what BuildIt does is takes specific inputs that you want and specializes the code for that particular input. So in this case, what I've done is I've specified the base to be a dynamic variable, which means I'm not going to specify what its value is. Its value is only going to arrive when I actually run the generated code. But I'm saying that the exponent is a static var, which means I'm going to specify you what the value for that is. And the way I'm specifying that is by passing it here as 15, because So you provide the entry point of the function that you want to specialize to this context object with whatever name you want to give it, and the arguments that are static. So if this had like more static arguments, they would all go here one after the other. And the dynamic arguments are filled in by the compiler, by the system. The system just assumes them as input variables to the generated code. So if I run this, what this does is it gives me a specialized version of power for the exponent 15. So now it only accepts a base and returns base power 15. This is very useful because now you can use this to specialize your implementations for certain inputs and in the process get performance out of it. Because running those general loops and running a generalized exponentiation algorithm is slower than running it this way. Okay, so now if I want to change the specialization, if I want to say, hey, instead of specializing for the exponent, I want to specialize for the base. You could make the exponent dynamic, and you could make the base static, which is now flipping the specialization. I'm going to keep the argument the same. So if I run this one, this actually gives me the code for any 15 specifically raised to whatever argument that you provide. So yeah, is it similar to proc macros? Yes and no, except okay, the difference here is that it's not done as a part of the compiler. This system is a library. So if you look at it, this is a standard C++ compiler generated code, by the way. This tool on the backend just has a standard Clang, or I think it has GCC running in the background, and it just compiles and runs. All you have is basically these headers included, and you have it linked against a library. So this is a very lightweight system that lets you embed things into embed programs into C++ or embed languages into C++. The other difference is that the first stage is running an entire C++ language. So it's not like a restricted language like Rust macros or proc macros. This lets you do anything and everything you can in C++, which means in this first stage you can open a file, you can create a hash map, you can do whatever you can, whatever you want in the first stage, and it will run that system, that program completely to generate your code. This is basically more flexible than macros. You can do a lot of these things that I've shown here with C++ templates or caused expressions, but again, they're the similar sort of drawback that the language is restricted in some way. You can't open a website or you hit a URL in your first stage in using const expressions. The other benefit that we have is the syntax for all the stages is exactly the same. So if you look at this while loop and at this if condition, they are normal while and if conditions. This is not a macro. This is not any overload of any like define this while as some weird lambda accepting object or anything like that. This is a normal while loop. The only difference we have is we use these special type templates that you use to declare your variables, and everything else works exactly the same. So if you want to switch between stages, you don't have to change your code. Like if you use macros, you have to rewrite a part of your code to sort of do different things. The resulting sort of behavior is the same as what you would get from macros, but the way you use it is very simple. This lets you do a lot more things very easily. If you're trying to fine tune your language, you can now like just change some types of the variables and it will give you very different implementations. That comes in handy, at least in my opinion. And the other benefit that we have here, which actually goes under the radar a lot of times, is that you actually can see the generated code. So because this explicit code generation approach, you see the generated code as C++ code or C code, whichever you want. And there's a lot of benefit for this. The most important benefit is that you can debug your code better. You can see the code that you're generating, which means you can see what's wrong if something is wrong. Unlike const expressions where you only see the first stage code and the generated code is sort of like in the compiler somewhere, or templates. Again, everyone knows it's very hard to debug templates. Yes, it's basically templates without using SFI and AE or using any of the template specializations. You just, if you want to have a conditional, you put a condition. You don't put a template matching there to specialize it for a particular input. It's C++ for generating C++. The other benefit of using generating C++ as opposed to like say generating LLVM or assembly even is that you can do a lot of reuse. What that means is this generated code, I can run it with an existing compiler like a C++ compiler, and it will do all the optimizations for me. I don't have to re-implement those optimizations myself. This is useful because I can also now generate OpenMP pragmas or CUDA code. I can generate Silk code. I can, like, whatever I want to target, I can generate. I can even generate. So recently we have a project going on which is actually generating HLS code out of it for running it on FPGAs. If we did the approach of doing everything ourselves, like we just generate optimized assembly, we could not reuse those systems. You can also reuse a lot of other infrastructure that goes with C++ in general, right? Like for looking at the generated code, you can like use your IDEs, or you can use your existing navigation tools. And yeah, generating C++ over generating assembly wherever you can is very useful. There are use cases where the optimizations that you want to express or implement cannot be expressed as C++ code because you're like doing some weird things that C++ doesn't support. Then you might have to fall back to generating assembly or generating LLVM, but do that sparingly. Try to use as much of the ecosystem of the language as possible, and that's what BuildIt does. So yeah, the high level idea is you write code using these mixed types, and it generates code for you. You can do this as many times as you want, by the way. Like if you want to have a nested, let's say a 3-stage execution, this is an example that shows how you can have dynamic of static or dynamic of dynamic, which basically generates code with the second stage. So if I run this one, yeah, you can get some code which again has BuildIt types in it, and then you can stage it again to actually get your final code. So yeah, you can have as many levels of nestings of these types as you want. Yeah, there's some comments. C++ as a backend language, interesting. Yes, C++ as a backend language is what a lot of DSLs do. Like we have developed Halide, we have developed Taco or Graphite. All those generate C++ code. How this would compare against CPP front by Herbstutter? I should check that out. I am embarrassed. I should look at what CPP front does. I don't have an answer for you, but next stream I will definitely have an answer for it. It's so good, high-level optimizations are so much easier. Yes, the focus here is not doing low-level optimizations. The focus here is doing domain-specific optimizations. So, for example, if you're writing like an operator that, say, maps a certain function to a set of elements, implementing that in something like this would make it so much easier because now you can generate different versions out of the same implementation. Something that the compiler cannot do, because normally if you write it using a for loop, the compiler doesn't know that this for loop can be sort of reordered or can be parallelized. But because you, the developer, know what you're doing with these operators, you can write it using a system like this and generate different versions based on what your input parameters are. Yeah. I'll get into like how you do high-level optimizations with this. In fact, we have an entire paper talking about doing analysis and transformations in BuildIt. Okay, did I just see brainfuck somewhere? Yes, brainfuck is an interesting use case for the system. So think about it high level. If you have an interpreter for a language which takes two inputs, the program that you're interpreting and the values that it's running on. And if you stage that interpreter or like sort of partially evaluate that interpreter in this setting, it actually gives you the code for that program. Like suppose you specify the program in the first stage and you specify the input in the second stage or mark it as dynamic. Now everything that is written using the first stage program is going to be evaluated, which means it's going to give you a program that specifically runs that brainfuck program. So in this case, what we have done is I wrote a very generic, simple interpreter for brainfuck which accepts a constant static BF program, and everything else is dynamic. And here I supply the program that I want to sort of stage this for in the first stage. And when I run this, it's a normal interpreter, by the way. If you look at the implementation, it just says while the program doesn't reach an end, just have a switch case on the operator and implement that operator. So the operator actually is implemented here, like it's a function that does what needs to be done. It basically says, like suppose you have plus, then it does tape of pointer equals to tape of pointer plus whatever the operation is modulo 256. And you have, like suppose the less than, then you have pointer equals to pointer minus how many you want to move. And this is a normal interpreter. There is no like compilerish techniques here. But when you stage this, it actually gives you like the program for that brain fuck program with like a bunch of while loops, a bunch of conditionals and so on, which is very useful. We have done, brain fuck is a sort of like not a useful thing, but we have applied similar things to regular expressions, and we have built a regular expression compiler out of just writing an interpreter for regular expression. And in doing so, we have done a bunch of optimizations in there. So yeah, it comes in handy. Okay, that's a lot about BuildIt. I can talk about this on and on all day. There's a lot more examples. We have built an INSUM DSL out of it in just like 300 lines of code. So you can write expressions like these, and it will generate like CPU and GPU parallel code for you. So again, not very optimized, just example of what you can do with it. So if I change it to GPU, then it will generate some CUDA code for you. All those things are built into BuildIt. But let's get back to the bug. If there are any more questions, please drop them in the chat. I'm happy to talk about BuildIt all the time. But we have some publications. We have some 3 papers over the span of 3 years, I think. Yeah, that we have added features to BuildIt. I've had a master's student who has built a system on top of it. That's an entire master's thesis, by the way. So a lot of work has been done. But yeah, let's get back to the bug that we started with. Hang on, this wasn't the start. Yeah, here we go. So this code normally doesn't have any static variables, which means that everything that you write to the dynamic variable should be produced as it is. Like everything is written using dynamic. So whatever you write should be produced as it is. And it mostly works correctly. It gives you a while loop here, and then there is a while loop here, but everything else doesn't make sense. Like there's a go to here, and then there is like where did this while loop go? It's all messed up, right? It's not right. So I want to get into why this issue is happening and how do we fix it. What I'm going to do is I'm going to draw some stuff for it so that we can understand things better. Let me see if I can get at least this part of the OBS to work correctly. Give me a second. I'm trying to share my iPad in this. All right. Yeah, I think. No way. Are you kidding me? Come on. I had tested this before. Let me try it again this time. Okay, so let's talk about how BuildIt works. So BuildIt, like I said, it's a library. It's not an operating. It's not a compiler, which means it doesn't have access to whatever your program is. Can you go back, show the input to get this buggy output? Yeah, of course. Here it is. I'm also gonna move this out of the way so you guys can see this. Yeah, it's a bunch of weirdly nested while loops, and there's an if condition that has a break inside it. And normally, if this worked well, it should produce the exact same code because everything is written using dynamic, so it should produce the exact same code. But instead, it produces whatever this mess is, which yeah, we need to work on. Yeah, we can get into this more. I can walk through this more. But yeah, so let's talk about how BuildIt works. BuildIt actually doesn't have access to your code because it doesn't see your code. It's a library. What it only does is implement these 2 types, dynamic and static. So everything that's written using these types is overloaded. So all the operations, including like plus, minus, constructors, destructors, everything is overloaded, and that's how BuildIt sees your program. So if I put up yeah, so what BuildIt essentially does is it creates a graph of operations. So if I have a code like this, let's say int x equals 5, or let's say dynamic int x equals 5, and then I'll do x equals to x plus 1, right? This is an operation. What BuildIt does is first it sees that a variable x has been declared of type integer, so it creates a node of decal type. So it says there's a declaration and the type is variable is x and the type is integer in its internal memory, and then it sees okay the plus operation is overloaded on the x variable. So it says I'm going to create x plus 1 as an expression in my memory, and then it's being assigned to x again, so I'm going to do x equals, and this gives you the first statement. This gives second statement. This gives you the first statement, and when it reaches the end, the program is ready, right? This way you can extract all sort of statements and expressions and create a program out of it. But what about conditions? What about loops? Which is what the current today's issue is. So for that, BuildIt actually cannot overload the C++ while condition or the if condition. That's a problem. So what BuildIt does is every time, suppose you write a condition like this. So actually, never mind. Let's write it here. Suppose I write a condition like this: if x equals 3, right? The first thing it's going to do is going to create a statement for expression for x equals 3, which is fine. And then what C++ does, if you write if condition around something, it tries to cast that to bool. This is the semantics of an if condition. So what we have done is, on the type that this expression creates, we have overloaded the explicit bool conversion operator. So we basically get a sort of a hook on whenever someone tries to write if on a dynamic variable or dynamic statement. When that happens, BuildIt pauses the execution. It says, okay, hold up, we have a if condition. I don't know how to handle this because I can't return, I don't know if x is going to be 3 or if x is not going to be 3, right? It doesn't know because x doesn't have a value yet. It's going to be a runtime parameter, or it's going to be coming from some input that I don't have. So what it does is, it says, okay, let's try to see what happens if x is 3. So what it does is, in that explicitly overloaded cast to bool operator, it returns true. So in this case, suppose I had at this point x equals to x plus 2, I had else x equals to x plus 3, right? So it returns true first, and the execution continues, in which case I get x equals to x plus 2 as the next statement, right? And then it says, okay, now the execution has reached the end, but hey, I haven't finished this program yet. I have only done an execution where that statement was true. What if it was false? Because at runtime it could be false. So what it does, it starts re-execution from the beginning. It goes back to the beginning of the function and starts executing it. And at this point, when it reaches this if condition, it returns false this time. So if I do this whole thing again, I'm gonna get the false graph, which looks like this. So we have a decal first, then we have x equals to x plus 1, then I have x equals 3, and then I will get x equals to x plus 3 this time, because we used the false path this time. Now I have these two different paths in the program. What BuildIt now does, it tries to merge them. It says, okay, now that I know these statements are exactly the same as each other, so are these, and this was the statement where I had sort of done a if condition, and then finally I have these two. So what it's going to try to do is it's going to try to create a single program out of this. So what this will give us is decal, then it will give us x equals to x plus 1, then it's going to give us if x equals 3, because it knows that x equals 3 was the one that triggered this if condition, and then it's going to say in the if x equals to x plus 2, and in the else it's going to give you x equals to x plus 3, and this is how the entire program is created. Let me quickly demonstrate this so that we can see if that's exactly what happens. I'll explain this again in more detail if needed. So let's start with the blank program. So let's write a simple program like this, like dynamic var of int x equals to, I don't care if it has a value, doesn't matter, and then I'm going to say x equals to x plus 1. If x equals 3, then I am going to say x equals to x plus else let's say x equals x plus 3. Okay, simple example that we have seen before. When we run it, this is what you get. So you get initialization, the increment, the condition, the first, the then calls, and the else block. What I will not talk about is the names of these variables. The names of the variables, because we again don't have access to the compiler, we cannot get the names of the variables. So BuildIt just creates names. It just says, okay, I see a variable, I'm going to give it a name. I'm going to call it var0. Who cares? It's generic code. You're probably going to run it through a compiler, not going to read it as much as we are, so it's fine. But we do have a special feature in BuildIt where if you compile your original first stage with debug symbols, it can then extract those names and put them in the generated code. So if you, in this website, if you just turn the var names flag on, and if you run this, this time it actually tries to preserve the names of the variables. So yeah, so now you get x_0 here. The numbers are still preserved because sometimes variables are duplicated, and you don't want to have like same names to different variables. So that's why it still appends like _0_1 at the end of it. Okay, there's some questions. Seems like a dense application of operator overloading plus enable it in BuildIt. Operator overloading plus enable if. Enable if shows up a lot because of how the overloading is done, because you want to do it generically for all types. So yes, enable if is used a lot, and a lot of operator overloading. But a lot of mechanism actually comes from how you, once you're extracted, how do you sort of like merge those paths, and how do you create sane looking programs. Otherwise, there's also a lot of optimizations here. So in our paper we talk about it. If you do it naively, there's an exponential blow up in how much time it would take to run this, because every time you branch you have to do a double thing. But we have optimization that actually lets you do it in polynomial time, in quadratic of the program size, which is again not great. Like quadratic is still expensive, right? You don't want to run it for large programs, but we have seen for the kind of applications that we build DSLs for, it's actually pretty scalable. Okay, so let's stop sharing this for a while. Yeah, so there's a next question here. Says, can we look at this as a way to merge entire program into one basic block as you're trying to merge branches? I wouldn't say it's a way of merging entire programs into one basic block, because we are still creating basic blocks. The generated code, okay, it doesn't have basic blocks, it has ASTs, but it still has control flow in it, and I don't think it's creating a single basic block out of it. But if the question is something else, please clarify. I'm happy to answer. And he's doing a data flow analysis to merge to a single basic block. It's not really a data flow analysis, because the way we do the merging is through this thing called static tags. I'm not going to get into enough details about it today, but what static tags essentially does is uniquely identifies each statement it produces across graphs. That way you can use those tags to like compare things and merge them into a single statement. Like if two statements have the same tags, they are equal, and then you can sort of merge them into a single one. It's basically graph collapsing. Like you have multiple graphs, it's collapsing into one graph that gives you a consistent view of the program. Yeah, we are fusing those branches. But what this also means is, if you have a statement like, suppose you have something else after it, like suppose I have a dynamic var in y equals to 3, and then I have x equals to y plus 2. This statement, if you do the naive execution, it's actually going to be in both the branches, right? Because at this point it bifurcated and it created a single program out of it. So what we also do is, from the back side, when we are fusing, we actually trim those statements and make a single one out of it. So here we go. When I run this, yeah, it puts that after the if condition. Let me actually go back to sharing my screen, and then I can explain how that happens, because that is relevant to today's bug, by the way. Again, foresight, because I know what the issue is. I promise I won't do that in the future. Yes. There we go. So yeah, if suppose I had another statement here which says, say, y equals to y plus 1, as it's declared, what would happen here is this execution would get y equals to y plus 1, and this would also get y equals to y plus 1. Now at this point, when it's merging, it sees that these two statements are exactly the same, so it puts it after the if condition, and that way your code doesn't have like just branches inside branches inside branches. So if you have like control flow one after the other, it actually comes up like that. How do you generate variable names, name locations via coloring? How do you generate variable names? Yeah, that's an important question. Because normally when you have a declaration of dynamic variable, at that point you can decide the name of that variable. It can just be like a zero or something like that. But the problem is you have these separate runs, right? You're running the program once and you're running the program again. Those are essentially two different names of the same, two different instances of the same variable. You cannot really tie them together. There is a so how do we actually cover names? So that goes back to using the tags thing that I talked about. If you can uniquely identify each statement across runs, you can uniquely identify two declaration statements of the same variable across runs. And that if two variables and their declarations have the same static tag, it means they are the same variable. So we have a pass after extracting the code. We have a pass that goes and numbers all the variables, and that's where sort of each unique variable is given a unique name. Yeah, we don't really use mangling because it doesn't make sense, because you could have two variables with the exact same type, with the same initialization and everything appearing at the same point in the code, but could have generated different variables. And it happens. So like if I had a while loop, and inside the a static while loop which completely unrolls, and inside that I have a variable declared, it's literally at the same location that the same variable is being created. Different variables are being created. So you don't want that to happen. It's based on the static tags. Static tags seem like magic at this point. I'll get into that later. Again, the paper talks about it. If you're interested, you can read about it. But yeah, I think it's too much of the implementation detail. Just for now, just assume that there is this magical tag which tells you. It gives you a unique name for each statement in your generated code across runs, by the way, not just for a single run. Okay, so let's talk about what happens if there are loops. We just showed what happens when there are if conditions, which is easy to handle. You bifurcate, you fork the execution, you run both the sides, and then you merge at the end whenever sort of like the code is done. What happens if this is a while loop? So let's put a while x equals to 3, and let's say y equals to y plus 1. Technically this is an infinite loop, but BuildIt doesn't care, because it's not like it knows anything about x either. So it's not gonna make this into an infinite loop. So what happens when I run this? Actually, you know what, let's turn bad names off for the next time. Oops, what did I do? Oh, x is not, y is not declared here. Yeah, so when I run this, I actually get a while loop out of it. So where did this magical while loop come from? That actually is the same trick. So we cannot really differentiate between if condition and a while loop from that overloading trick, right? We overload this expression being casted to bool to identify if loops. I draw the, oh sorry, oops, I did not move the page, sorry. Thanks a lot for reminding me. Yeah, what I was showing was if I write a while loop like this, it produces the same while loop in a generated code. Where does that while loop come from? That's the thing I was getting into. So yeah, the idea here is that this while loop also needs a Boolean condition, right? Like it needs a condition to say, am I running or am I not running? C++ doesn't have a way to discriminate that between like a if and this. The only thing we have is a cast to bool. So we continue with that. We say, okay, let's think this is an if condition. Let's assume this is an if condition. There is no special while loop statements. Now what happens is this continues as before, and it produces a if x equals 3. Then it produces y equals to y plus 1. At this point, the execution goes back to 23, right? Because we have returned true, it's going to run the loop and go back to 23. When it goes back to 23, this is where the static tags come into picture again. You start running x equals 3, and now you realize I have seen this exact statement before. Because, okay, let's actually put my screen up again. Maybe that's needed. Yeah, so you guys can see this, right? So, okay, so suppose we have a statement, then we produce another statement, and then we have the if condition. So it's like x equals 3. Then I do y equals to y plus 1 because I took the true path. And now BuildIt says, okay, the execution goes back and it sees x equals 3 again. Actually, no, it doesn't see it this way. What it sees is, it doesn't know it's a package, right? All it knows is I see x equals 3 again. And it knows that this x equals 3 is exactly as this one, because this has static tag s1, this also has static tag s1. Like I said, these are unique identifiers for statements in the program. Now, because these two are exactly the same, BuildIt says, hold up, something is wrong. I don't think I need to continue the execution. I think if I continue this, I'm gonna get the same program over and over again. I'm gonna get y equals to y plus 1, I'm gonna get x equals 3, and this is gonna keep on happening. So let's put an end to this, and let's just, instead of putting like generating this code again, what it chooses to do is just, oh sorry, it is not have all this and produce a goto in here. So it says, let's say go to s1. So it says, now I'm just gonna like continue execution and put a go to, because I saw a statement, then I see the statement again. It means the execution is gonna continue like this forever. Then it takes the false path, in which case liveness analysis sort of thing. Not really liveness analysis, it's mostly just control sort of path analysis in some way. Yeah, so then it takes the false path, in which it gets sort of a if, oops, it gets the previous statements, then it gets a if x equals 3, then y equals to y plus 1, and then gets a go to s1, right? The else path doesn't do anything. The else path in this case, if the while loop fails, then it just if the condition is false, it just gets out and it does whatever comes after this, and then there's a s1 here. Now what it basically gets is a if statements and go to S1, which is going back to the start of the if condition. And then, so this is what it initially extracts. When it runs the initial passes, this is what it extracts. It sees a statement, if condition, and a go to back to that statement. Then it's in the later passes, when it's done extracting, we do a pass that converts this into a while loop. It says, okay, I have a statement going back to a condition, so this is like a while loop. So I'm going to put it into x equals 3, y equals to y plus 1, and that's what we get. This is how BuildIt sort of extracts while loops. Although, remember, this is very different from having a statement that looks exactly the same. So, like suppose I have x equals 3, and then I say y equals to y plus 1. Oh, I'm going to hide my thing. Sorry. Yeah, so suppose I write a loop like this. Okay? Like if I had a statements like bunch of statements like this. This is not going to give us a loop if you look at it. Yeah, this just gives you what you expected. So like var 0 equals 3, var 1 equals to var1 plus 1, and then var 0 equals to 3. This is because these two statements do not have the same static tag. They look exactly the same, but they do not have the same static tag. They in fact have different static tags, which means BuildIt says, okay, this is a new statement. I'm going to continue execution and see where it goes. And that's why it doesn't get a loop out of. Even if this was a if, even if this was like a if x equals 3 kind of a thing, it would still, or let's say this was even inside it. It's not even, yeah, even if it was this way, it would still not be a loop. It would just be a normal statement. Yeah. Or even if let's make it even more clean, let's say I did this. Like I suppose I copied it 5 times, like to just fool it. Let's say it's running 5 times. It should think that these are a loop now, right? But actually it just, yeah, you just get 5 different conditions one after the other. So yeah, this is the whole sort of thing about static tags. Static tags uniquely identify where you are in the program without like yeah, getting fooled by these kind of statements. So yeah, that's how extraction works. And so clearly something is wrong. If we come on, let's see. It's in a separate tab now. Yeah, so clearly something is going wrong, because when I run this one, I do not I should get a bunch of while loops, but it produces something weird. If you're worried about nested while loops, those work properly, by the way. This is not because of just having nested while loops. We have obviously tested this aggressively before, and we have a lot of test cases that check this kind of a thing. It's not because of just having nested while loop. Let me actually show you. So wow. So, I'm just creating like some nested structure. Yeah, we stage this, we get exactly what we expect. So actually, let me do var names to make it clear. Yeah, you get your x and y's. The y couldn't be extracted here correctly because yeah, so it does, it tries to extract as much as it can from the debug variable. Sometimes the C++ compilation doesn't preserve the variable names, and it becomes a mess. Like I think what's happening here is that this y is never used, so the debug symbols don't actually preserve those y's, and that's my guess. It could be something else too. I can look into it. Why it's simply so. Okay, the y name it couldn't extract, so actually maybe if I move it to the top, it will extract it. Unless something is horribly broken, which I don't think it is because there you go. Yeah, so now it extracts y base, and then the loops look exactly like you expect them to look. So this is not a problem just because of nested loops. It's in fact we have written giant applications which have had like 13, 14 nested loops generated, and it produces exactly the correct code. It's a combination of I'll tell you what is wrong with it. If you look at the original code, there is a while loop with a break on a condition inside, followed by an empty while loop, and there's a whole while loop around it. If I actually remove this while loop, okay, if I actually remove this while loop, this actually works perfectly fine. It gives you exactly what you need. Uh, yeah, this is what we wanted, right? Like while one is not equals, while 0 is not equals to 0, if break, and yeah, so it is a liveness of sort where the variable lives at the end of the block. It's not just variables, it's an entire statement. It's checking if that same statement shows up again. You're talking about the loop analysis, right? Yeah, it's about saying if the control flow reaches the same point it has reached before. So what BuildIt essentially does is while it's running, it keeps track of all the statements it has seen so far, and if it sees anything, the same statement again, it puts a loop. So it has nothing to do with variable liveness actually. Like variables don't even come into that. It's just statements at that point. Yeah, so this is the problem comes because of this exact sort of combination of having a while one like this followed by like this weird combination. Like if I had something else here, like suppose I had uh, k equals to k plus 2 here, it's, I think it should work this time. Yeah. Oh no, wait. There's still the bug here. Yeah. So there is some like combination of things that is causing it. Yeah, also, by the way, you don't need to have complete statements. You can, is it possible to show the input and output side by side cyberts column? Yeah, of course, I can do that. The easiest way to do that would be to have two tabs, I suppose. Actually, let's go back to, actually, let's just do it in the terminal. I think this is high time we go back to the implementation. Anyway, so what I've already done is I have, normally, okay, I need to just, I'll do that in a second. Let me just build it once quickly. Oh, I hope nothing crashes. OBS takes a lot of memory, by the way. I'm not sure why. Still compiling. We have a lot of samples. 1490 GPU. When yeah, I don't have the money to buy GPUs, man. Honestly, I think I'm mostly done with GPU research. In my first 2 years of PhD, I did a lot of GPU programming, mainly CUDA, for graph applications. So we're optimizing graph applications to run on GPUs. Wrote a lot of GPU code. I don't think I do that anymore. I do it in the context of writing DSLs for GPUs, but I don't write high performance GPU code myself anyway. So having a small GPU locally, plus we have a bunch of servers that are GPUs, so that works. Yeah. Okay, so normally when I have a fresh copy of BuildIt forked and compiled by the way, and if I do make run, everything works fine. All the samples and test cases pass. But let's look at this new sample case. So sorry, I need to move this slide out of the way. Actually, pull this mouse out like this. Uh, Yeah, so I have copied the sample here for your convenience. And what I've done here is there's a no test flag, which is don't run this buy a cheap 3060 GPU. I have 3060, I think. I have a GPU built into my Dell XPS 15. But and it is running through the GPU. I launched it to the NVIDIA whatever GeForce thing. It's just the memory is like the host memory is I think what it is trashing, which is why it's taking too much. And I have 64 gigabytes of memory. I think what's happening is WSL has 32 gigabytes reserved. I should try to reduce that. Like I had increased that before. Like I had let WSL have more memory. I should probably reclaim some of it back, at least when I'm running streams, so that yeah, OBS won't complain. But anyway, so if I comment out this no test flag, we should yeah, yeah, make an issue. This is the output. What I'm gonna do for your team here is again. Oh, wait, what's that? Yeah, ignore the stuff that's in the before the bar. It's basically how the internal representation of it looks like. That's why I would stick to Fedora. Yeah, I would like to stick to Fedora, but I can't play Dota on Fedora. I guess that's. I mean, if there's a way to play on Linux, please let me know. Okay, yeah. So this is the side-by-side comparison of the code that we wrote and what you see. I'll try to bring it to the same level at least. Okay, yeah. There is a while one. The while k not equals to 0 is not a loop. It's converted into a condition. And then we have the if var equals 0. And then there is the while k not equals to 0, which is supposed to be after the if, after the while loop. So I think that's usually fine. Like it's basically saying there's a break here. Instead of the break, I'm gonna put the code that comes afterwards here, which is fine. It's semantically correct code. But the problem is the else is completely broken. So like you have a if var not equals to 0 and then there's a break inside a if and then there's a go to label 1. That just seems wrong. So what we're going to do is the first smell that I get here is something is wrong with the loop analysis pass. The pass that converts existing loops into sort of control flow into loops is broken. So I'm going to disable that pass. Let's look at what it produces without the loop analysis. Just give me the plain jumps and go-tos. So there isn't a convenient way to do that in BuildIt right now. Except we have something called feature unstructured. So what you can do is in the context object, you can say context dot feature unstructured equals true. What this does is it tries its best to produce unstructured code instead of structured code. So no loops, no for loops, anything like that. But this also does something different. This does more aggressive memorization. So it would not produce code that's even close to what we see. This is mostly for like high performance applications like regular expressions where you are trying to create control flow that is inherently not structured. I'll talk about examples of code that's cannot be structured. Like imagine things like if you have, I mean, you have seen this in basic in compilers before, right? Like if you have basic blocks that I can talk about examples later, but yeah, so this is for those kind of programs. But this we are going to use this. This has more other things that it would break. So what I'm going to do is I'm just going to manually let's do Control V. I'm going to manually disable. I'm going to manually disable the loop finder passes and everything that runs after it. So we basically have a sequence of passes that run. So this is the initial extraction pass that goes and extracts the actual function that we are trying to run. And then this is the naming pass, which goes and names all the variables, the var0, var1, whatever. Then we have a sequence of passes that deal with the labels. So the labels that we produce actually need to be inserted in the code later because labels are not statements. So these three passes together insert the label into the generated code. And finally, we have some cleanup passes. So we have some sub-expression cleanup passes. What this does is if a particular sub-expression that's not that's sort of like duplicated, it cleans this up. It's like it's an important cleanup pass that we have. It's important. And then we have some redundant elimination variable elimination pass, which is basically if you have x equals to y and y equals to z and z equals to a, it cleans those up. Like it collapses all those assignments into a single one. That makes cleaner code, and that actually shows up a lot if you write abstractions using BuildIt, and if you have like functions taking arguments. There's going to be an assignment catered there. You don't need those assignments, so it cleans those up. It's a syntactic cleanup pass. And this is where we're going to stop. We're going to say, okay, now that this is done, return whatever you have. Don't actually run the rest of the passes, which is like the loop finder pass, the for loop finder pass, the if switcher pass. The if switcher is a sort of a pass which, suppose you have an if condition with no then, but it has an else. It flips the if condition. It makes the changes the condition to a not and keeps the then, just to clean up it, make it look prettier. And then there are like some other passes that run. So I'm going to disable this. I'm going to put a return AST here, and I'm going to see if this produces something that's more legible. By the way, please feel free to stop me and like drop comments in the chat if you need something to be explained more. Now that I run this, okay, there is no if conditions anymore, thankfully. But there are like, so there's no while loops anymore. There is if conditions and there is jumps, which is what is still correct. So we have the outermost while loop has become into a label 0 and go to label 0. So that's good. The inner loop is also fine. We have a label 1 here and a go to label 1 here. But this is where the problem is. We have a go to label 1 here, which jumps to this label. Now the problem is this label is not in the, like, it's not in the same sequence of statements that this label 1 is jumping to. Like, it's jumping to a branch, to a different branch. This usually in C is fine. Like if I run this code right now, it's going to run fine. It's going to run and produce the correct code that I want, because essentially you're jumping from this point. Let me open the example again so if it's clear. Yeah, so at this point, if I have this go to label 1, it's actually going to jump to this label, and that is okay because that's behaving like this while loop. So this line 6 to 5 is actually moved to where the break is, if it's not clear. So what's happening is this, and actually this is the loop, that is this loop 6 to 5. It's squeezed where this break was, because it's fine. After this break, it's going to run this anyway, so it just moved there. And the other part has a continue. So the else part goes back again. The else part basically goes to like label 0 and then goes back. So that's how it's implemented. But there's a problem here. Like this go to label 1 is fine. There is another if condition here, which is generated out of thin air. This doesn't exist in the original program. But this also has a go to label 1 here. Where did this come from? That's the heart of the problem. Again, this is very hard to see what's happening here. So what we're going to do is actually, I talked about this collapsing of the graphs, right? Like when we create multiple runs, we try to collapse the graph from both front and the back. And that gives you sort of this single control flow. We cannot be sure where this else came from. So what we're going to do is we're also going to disable that method of like cramping things, trimming things on the back, and let it give us the simplest code that it produced initially. So let's see that. The way that is done is okay, so we have this impl function, which actually, sorry. But I use ctags extensively, by the way, so that might be a good point to show that. So yeah. That's how you jump between the other half about IDEs, that's code navigation. I use ctags. If you have not used ctags, I can talk about it at some point in the future. It's a great system, use it if you can, for C++ and C at least. So yeah, so what the execution does is once it has extracted the true path, so it creates, so when the execution stops on an if condition, an exception is thrown. At this point, the control reaches this position. At this point, it creates two contexts, a true context and a false context, and it starts the execution for both of them. So once, I'm not going to go into too much details of what happens, but by the time it reaches this point, both the runs have completed and it has created the true AST. So we have a true AST when we have a false AST. it does a trim at offset, which means it says remove everything up to the point where the condition was. That's to like sort of merge them from the front. And then what it does is it also does trim common from the back, which is says, okay, you have some statements that are coming after the if condition. Let's merge them into a single one too. And this is what we're going to disable. We want to have a tree of statements rather than a DAG of statements. A tree is more easier to look at than a DAG. So let's fix this. I mean, I will just comment it, but I also need some things out of it. So what I'm going to simply do is I'm just going to return. Actually, you know what? It's a copy return statement from the end. Sorry, this is all over the place because I've bumped up the font. But you know what? Actually, let's close this for a while. Yeah. Yeah. So we're gonna take this and put it here. Yeah. So it's gonna not do anything. It's just gonna return the default value from this function. Let's see if you want to. Oh, what did I do? Sorry, it should be after the declaration. Yeah. So yeah, so now I have disabled the trimming from the back part, which means now if you see a if condition, it's gonna have the entirety of the remaining program. Like it's still gonna have if and else, but everything is going to be there on both sides of the branches. Let's actually look at a simpler example before we look at what this does. So what I'm gonna do is I'm gonna just comment this out with the bad code, and I'm gonna show an example of what this means. Let's say if k equals 0, let's say p equals to p plus 1, else say k equals to p plus 1. Okay? Normally we would get a if condition followed by that statement afterwards, but this time we're gonna get just a normal statement with everything that comes afterwards duplicated. So everything is like completely it's a tree of statements basically. There's no more if conditions. What this also there's no more sort of merge statements. What this means is if I had another if statement after this, so if I had like say if t and let's say t equals to t plus e else t equals to t plus 4, something like this. Oops. My keyboard is kept in a location that I'm not usually used to because I have the iPad in front of me. So yeah, what this does is it duplicates everything that happens from that point onwards and never trims them from back, which means you get something like this. Everything is sort of like a if with a if inside, and everything that comes afterwards is in both the branches. Like you can see that this entire if condition is duplicated, which is useful. So there's benefits of looking at this view in that it lets me understand what exactly is going on, like what is going wrong. Why is something failing when it should not be failing? So let's actually go back to the original code. Any questions about this? By the way, I can take those. Yeah, so I'm gonna bring back the code that we disabled and let's look at what this does. So I'm gonna do this. Start the code in front of us. Yeah, so we do have the outer if condition, which corresponds to the while loop. Sorry, which corresponds to this if condition. The thing you have to know about BuildIt is BuildIt cannot intercept while ones like this. They are not really conditions, so it's not going to put a condition there. It's just an unconditional loop at the end. So this go to label zeros will directly go to this label 0, which is fine. But the eventual extraction pass will make it into a while one. If there's like a unconditional loop, it makes it into a while one. So okay, so we have a if var 0 equals to 0, which is correct. Inside that we have if var0 equals to 0, which is this, and then we have the break, so it will go to this. So we have if var0 is not equals to 0, that's perfect. In that case, we have go to label 1. Go to label 1 goes back to this, which means it's a while loop. If that while loop gets out, then it goes to label 0, which is going back to the original while loop. So that's also correct. In the else part of this if condition, we have go to label 0, which means it's if this does not break, then it goes back to this label 0, which is the start of this loop. So that is correct. This part is correct. If this entire condition is false, then it has the if var not equals to 0, which is this loop. You know what? I'm going to actually make this more easier to read by making those conditions slightly different. Like instead of having this as the same over and over, let's do 2 and let's do 3. But I should have done this before, but I just had from whatever sample I had and broke. Okay, so this time we have the 1 loop, which is here, then we have the 2 condition, which is here, and then we have the 3 loop here. In the else part of it, we again have the 3 condition, because if this loop does not run, if the 1 loop doesn't run, then the 3 loop would run, or whenever it breaks, the 3 loop would run, which is correct, and then it has the same thing copied over as before. So at least at this point, it's almost correct. You can say it's almost correct. In that, these things are fine. There's label 0, except that when this if condition is created, there is a label 1 here. Go to label 1. This label 1 doesn't exist on this branch. It exists on a separate branch here. See, you see, that's the problem. You have a label, go to label 1, which is not in the same branch as this if. Now, why did this happen? We duplicated the code, right? So everything, including the loops and the jump targets and everything, should be duplicated, not just the go-to statements. This is where the extraction logic sort of comes in. Like I mentioned this briefly before, that BuildIt doesn't actually see statements or jump targets. It never actually knows that here is a label here that I could jump to. All it sees is where you're jumping. So when the port extraction happens, all it sees is go-tos. It doesn't know where a particular label is. So what it does is, it goes back and inserts labels later. So actually we showed that pass here, right? So yeah, so we have this pass, which we have 3 passes. One is label collector. It goes and identifies all the labels that we have to jump to. Then we have the label creator, which creates all those labels. And then we have the label inserter, which goes and inserts all those labels in the right position. What's happening here is, the label that we just created is a unique label, because these labels are identified by the static tags. Everything in BuildIt is done using static tags. So when the jump statement is created, it remembers where I'm jumping. So what static tag am I jumping to? The static tag it's jumping to is the same for both these state locations. Like this loop and this loop is exactly the same, right, in the original code. So those static tags are exactly the same, which means it says I'm jumping to the same location as this location. The problem is that the creator is only creating one label, and it's inserting it only once, which is causing this whole like label to jump to the wrong one. What we would ideally want is each copy to have its own sort of jump target and then jump to it. Now you might ask, why did this not show up before? Like, obviously there are loops after loops and things are jumping to multiple locations. Why is this the first time this is happening? So usually what happens is, whenever you have if conditions one after the other, or a simpler case actually, let's remove this if while loop that like we had done before. This should still have the same problem, because there's a while loop afterwards, there's a while loop in the middle. This should be duplicated across both the runs, and it should have the wrong code. So let's see what this does. Like what is that special about that outer loop that makes this error show up? So yeah, if you look here, there's the same problem. We again have a label 1 here and a label go to label 1 and a go to label 1 here. This is wrong. Like this statement itself is wrong. But the point about this is never created, because we have now disabled the merging from the back path. This actually disappears. This if condition never appears. It gets merged with the other one. Let me show you how it gets merged with the other one. Actually, we need a simpler example for that. So let's say we don't even this. We don't need that if condition. It's part of the problem. Yeah. So in this one, simple example, we have a if, and there's a wait what? It's one after the other. Let's make it even simple. Let's make it into simple. Right? It's just will demonstrate the same problem, and it's possible flex. Yeah. So this one, let's look at this one. Okay, so we have label 0 here, and we have go to label 0 here on the else part. This is because we haven't merged from the back. This is a problem. This is not good code. But the problem is this never happens. If you look at the generated code, because we have now disabled this merging from the back part thing, normally these two statements get merged into each other, and we only have one of them. So the label creator only creates this one label 0 and produces the right jump. So let's actually go back and see that. So if I don't do the trim common from back, this like if I don't do this, what does it produce? Let's see. In this case, it gets merged. There's a loop afterwards. It has its own label. It has its own jump target. So that problem doesn't appear. And this is part of the design. We try to merge everything into a single thing. That way, these labels do not have to be duplicated. These labels do not have to exist differently. And that's why we don't see the problem in normal use cases. So what happened here? Why did this sort of merging not work when we had a simple, oh, sorry, we had a simple, let's say, when we had a simple code like this? What? This one is merged. Yeah, when this whole while loop shenanigans happened, yeah, so why did this if condition not get merged with this if condition? They are statically the same and they appear on different sides of the branches. They should essentially get merged into one. So what happened here? Why could these not be merged? So the answer is simple. Whenever you try to merge things from the back, it does it sort of looking at what it currently has. In this particular case, what happens? So there's a nested if. There's this if, and it has an if inside it, and this if has the if I'm trying to merge with. It's not in its sibling. So like when this then part is the sibling of this else. If you look at the ends of those two, they're not the same. This one has an if condition inside, while this has a one here. Now, this could have been more. Okay, you know what? I'm going to copy this into some text file, and then you can edit it on the fly. Oops, sorry. Yeah, so I have this code, right? The one way I could merge this was if I pulled this out, put it here, and in the else I did go to label 0. Does that make sense? If I did it this way, had this code in the if part, right? And then the else part was obviously going to label 0 automatically. So if I squeeze this label 0 here, semantically no change, and then I now because this else has a go to, I can just pull this out. I can say, okay, this doesn't need to be inside the if anymore because the else part is never going to reach here. Now I have this. At this point, these two can be merged. Like now, this and these three statements and these three statements are exactly the same, which means they can be peeled out. So what we could get now here is this could be removed, this could be removed, it could go here, and then the label one would just go here. If we did this, we will get the correct code. Now, why is BuildIt not able to do that? Because it cannot reason about this magical transformations that need to be done to make this code be sort of least deduplicated. It does it opportunistically. It's a heuristic. It says, okay, I see two statements in the back of the same of the then and else. I'm going to try to merge it. And that's what, and it fails to do that because it cannot like speculate, magically insert go-tos in the middle to sort of avert this problem. It's semantically correct, but it doesn't look the same. So that's what we want to. Okay, so now one solution might be to fix this. To say, okay, I'm going to try to create this such a way that this duplication never happens. And yes, that is exactly interesting. Bottom-up versus top-down way of analysis has a pattern code generation. This is doing sort of bottom-up code generation. It's like trying to see, okay, what can I merge this with and so on. You don't have a whole program view. You're not seeing the whole structure and trying to make it into correct code. You're trying to do small things. You're trying to build them together, and you don't have the global view, so you can't do the correct things. Yes, and I do not believe in making it possible to avoid deduplication. I think deduplication is necessary sometimes. Sorry, having duplicates is necessary sometimes. The problem is not because that it's creating duplicate codes. There are other reasons, by the way, why duplicate code can happen, which comes from our static variables. So like sometimes we have static variables affecting what dynamic variables is generated. So for example, if I had, So for example, here, if I had a if something, let's say if k and it has its then and else, like I'm going to just write it here like this. Hopefully no one cares. And then if I write k equals to a static variable, which is like say dependent on one of those previous ones. So like suppose this was k equals to okay, and suppose in this, if I'm doing actually, let's make this right. Let's say x equals to 1, else x equals to 2, and then I do k equals to x. Okay, let's think about this simple code. In the if part of the execution, it's going to do k equals to 1, and in the else part of the execution, it's going to do k equals to 2. Now, even though these two statements are static tags wise the same because they are coming from the same expression in the original code, they are different statements. I cannot merge them because they're semantically different. One is k equals to 1, one is k equals to 2. So we need having duplicate code sometimes. It's part of the requirement. What we need to handle correctly is if a particular piece of code is duplicated, the labels should be also duplicated and they should have different names. So if we the original code that we had, one simple way to fix this code, instead of trying to rearrange it into something that makes sense, I could just do, and this one is completely correct. This would be perfectly fine because now you have if that label that goes to that goes to its own label, this goes to its own label, and everything else is consistent. And when the loop analysis pass would run, this would make this whole thing into a while one. This would make this into a while, and it will make this into a separate one. And that's fine. It's still correct code. This is what we want. We want a mechanism of like creating duplicate code and giving them different labels if the labels are also duplicated. In the 3.5 years that BuildIt has been around, this problem never showed up. Like we never had a test case where if this never had a test case where a label was duplicated and there was a mismatch in the jump. This unfortunately never happened, but thankfully Vedant was working on some examples and he found this example where he stumbled upon it where he saw that the code was pretty strong. This is what I would do too if I were it in my hand. Yes, if If I was doing it by hand, yes, that we would normally have different labels. We wouldn't jump to a label in the middle of another if condition. Even though it's correct. It's correct. In C, you're allowed to jump to a different if condition. It skips over initialization and so on, but that's a different problem. C allows you to jump to different labels. And it would, in this particular case, it would still be fine, like it would run correct. But what also happens is because you don't have this structured control flow thing, the while loop extraction pass craps out. It says, okay, I'm going to try to extract loops, and for extracting loops, there should be structured control flow. I don't see it. I'm seeing some weird control flow here. It does its best job and fails, and then produces wrong code. Ideally, I should have like asserts inside the code that say, hey, this does not look like structured code. Am I doing something wrong? But the pass was written in a very different way. It's a bunch of heuristics tied together, and it doesn't it's not able to reason about this correctly. But the way we're going to bypass this problem is by whenever there's duplicated code, we also going to duplicate the statements. Yeah. It's not as simple of a job as I described it to be. Actually, we have actually reached the end of our time today. What would people prefer? Would you guys prefer me continuing for like say another hour, or would you guys prefer I stop the stream here and come back to it in the next session? I could do the next session like maybe the next weekend. Actually, I couldn't do the next weekend. I have to move it to the weekend after. Continue. I have one continue. If someone else needs to run, I have 5 viewers right now, so I don't mind continuing this for another hour and fix this and hopefully have a running code. But if someone needs to go and is really interested in watching live, please let me know and I will. We can figure out if I need to continue or move on. I was hoping this would go faster, but I didn't realize how much background I need to cover. Yeah, so I have 5 viewers. If any of you guys need to leave, just type in the chat saying continue or leave, and I can. I'm assuming blessed means continue. Is that right, Sam? Yep. So I have a green signal from two of you guys to continue. I'm actually in the mood to continue too because I didn't want to have this like bug lying around for too long. Especially because writing passage to generate custom jump tables for switch cases handwritten is hard to get correct semantics. That is, I know. Part of the problem that there is a lot of interesting control flow you can generate out of a compiler, like BuildIt basically. Like we have generated some insanely hairy control flow that just is correct. And writing that by hand, oh my god, it would be hard. Because what happens is once you have control flow, now you can use the control flow to actually also generate different code based on static variables. I'll show you some examples of that later. What we have done is like we have generated some code for GPUs where we have generated different code for each thread. Like we have written one implementation that does matrix multiplication, but each thread gets entirely different implementations generated based on like what parts of the matrix they are accessing, and it's optimized for those threads. And that writing it by hand would be difficult. So using compilers to generate code is actually a pretty neat way of optimizing your code. Okay, so I'm gonna take like a minute break here, just use the washroom, get myself some more tea, and I'll be back, and then we will continue it here. And then obviously this will be on the YouTube on the Twitch for 7 days. So if you guys need to look at it later, if you need to run, you can. And I think we can continue this for another hour and fix the bug, and hopefully we'll have a nice PR merge and everything. So yeah, I'll be back in a minute, and in the meantime, stare at the code if you need to. Alright, I am back. So there are some chat messages. Wouldn't to do a recursive gen create new labels for every while? That is correct. We are actually doing recursive gen, right? We are. By the way, if is everyone back who is hearing me? We are taking a break. So let's actually give it a minute. Also, in the meantime, I'm just gonna try to see if I can get my earbuds to work correctly again because I've been told the mic isn't great. Let's see.
Hello, hello. Can you guys still hear me? Someone let me know in the chat if you can still hear me. I think OBS is picking something up. Is this better than before though? Or is it the same? It's possible OBS is still picking up the same device. But if you can hear me better, I can switch to this device. It's more crisp. I guess that's better. Um, what I was doing previously was I was using my laptop's mic to use because my Bluetooth wasn't working properly. Uh, I will get a new mic the next time I'm streaming for sure. I promise you that. But for this like remaining part of the stream, do you want me to continue with the? Okay, so I'll continue with the buds then, and hopefully that's not too much of an issue. Yeah. So let's get back into the issue. Yeah, there was a comment saying, wouldn't recursive gen create new labels for every while? That is true. Normally, the we are doing recursive gen, right? Like we are trying to create code for each path and then merging them. The problem is we don't create labels while we are creating the code. We just create go-tos. We just create go-tos. And the go-tos internally, let me actually show you how the go-to statements look like. Oops. Uh, okay. Yeah. If we, uh, yeah. So this is the class that represents a go-to statement. It is basically here are the two things. It has a label that it's supposed to jump to, and then it has a temporary label number. So this tracer tag is, by the way, what I was talking about, a static tag. This is what uniquely identifies a statement. So when we're extracting the code, it basically just assigns this temporary label number. So when a go-to is extracted, when you see that you are going back to a statement that you have seen before, that's the point where you put a jump, right? The problem is that creates a temporary label number. It just assigns a temporary label number, and then we go back later and create those actual labels, and then put the required label number. Yeah, it's like lazy evaluation. It's not lazy evaluation, but like we couldn't do it before. The label doesn't exist. Now I could create a label at that point. The problem is that label would also be sort of shared or copied because BuildIt does. Okay, there are multiple issues with actually creating labels upfront. In that, sometimes you move things around as part of the extraction. So if I create a label in the middle, that label might get moved. And I don't want that to happen. That's a potential solution. I haven't looked into it. Like maybe a solution is to just create labels as soon as there's a go-to target. Like whenever you're creating a go-to, check if there is a label around that. If a label doesn't exist, create a new one. And then when you're like copying statements, make sure. Like, so another other optimization BuildIt does is what is called a memoization optimization. What this means is it? I'm gonna close this for a bit. Need this. So yeah. So what we do is when you're executing the code, if you see a statement that you have seen on the same run, that's a go-to back again, right? Like if you see a statement static tag that you have seen before, it's a go-to back again. But if you see a statement that you have seen on a different run, not on this execution, like if you have seen a statement that you have seen on some other execution, we do what is called a memoization exception. So it basically stops the execution there. So it says, okay, I have seen this tag has been seen on some other execution. What it does at this point is instead of like continuing the execution, it throws a memoization exception. This memoization exception is, let's just yeah, it's caught, and what it does here is it just copies over the statements from the other execution into this one, without doing a deep copy, obviously. There is a reason why we do it this way. This is the optimization that brings our execution complexity from exponential to polynomial. Because if you kept on executing everything, you would rediscover all the control flow that comes up afterwards. So if you see another if condition afterwards, that if condition would also have to be explored, and it would also have like its further if conditions and so on, and all those would need to be merged and merged and merged, and they have to be done again and again on every sort of branch. To avoid this, we just say, okay, if I see a statement ahead, I'm going to just copy everything that comes up after it, which means if there's an if condition afterwards, it's copied exactly as it is without actually having to duplicate it. And that saves us a lot of execution time. It actually brings it down from exponential to polynomial. We have a proof of that in the paper too. And this process is top down, right? The process of extraction is top down, but the process of merging is bottom, like from back to front. So that way, statements it's still inside out, like the innermost if conditions will still be done before the outer if conditions, but statements that come afterwards are done before a statement is that comes before. Maybe I don't think it's a BFS versus DFS difference unless I'm getting what you're saying wrong. And let me actually draw it. I think drawing would make it much simpler to understand. We have again the only way I can explain those things is with drawings. This is too abstract sometimes. Yeah, that's the part about compilers, right? Compilers are dealing with program as data, and that never goes well. Okay, we have our, I'm gonna move this to the side. I'm gonna turn it on from OBS. Cool. Yeah, so here's what we have. Suppose I have code like this. If x x equals to x plus 1, else y equals to y plus 1. Okay, and then I have another if y x equals to x plus 2, else x equals to x plus 3. Now, if I do this naively, if yeah, feel free to skip this if you're on time crunch. I think I'll quickly go through this. So no, this is also important to our optimization. Or what we're trying to fix, this is also important to that. So yeah, I think this is this. I wanted to get to this anyway. So what happens is if I start execution, if I draw the graph for it, what is the original graph? I have this, then I have this, right? This is our original program. This is like a if condition, and these are the two like four branches. Normally, when I execute this, I'm going to color code these. So the first run, which is true, like taking the true branch on the first and the true branch on the second, would go and follow this path, right? Then you would have another one which goes and let's say green, which follows the true path and then follows the false path. And in the same way, we would have say blue, which does false and then true. And then I'm gonna do one more color. What color is left? Oh, yellow. Uh, it would do false and then do false. So how many runs did we need? We need a total of 4 runs, right? We need a total of 4 runs to make this program extracted. But instead, if we do memoization optimization, here's what happens. We first, I'm going to draw the same thing again. The first path runs as it is, so the black path runs completely and gets this code, and all these nodes have been visited. Now, when the true false path run, which is the green part, it runs like this. Sorry, yeah, it runs like this. It runs like this, and then it goes here, and then it comes back, right? This is also fine. It has extracted. Now at this point, this if condition has been completely extracted and made into an if condition. Now when the blue path starts, it runs like this, and it reaches this point, and it says, "Hey, I have seen this exact thing before. I don't need to do it." So it stops here, and that's it. That's done. We don't have to execute anymore further. So this brought it down from 4 to 3. Right? We only had to do 3 runs for this. But if you sort of have multiple ifs like that, it actually comes down from exponential to polynomial. Because we don't have to, if there's like another if condition after this, those would also not be visited. So it saves a lot of runs actually. Normally it's like 2 power n, where n is the number of if conditions. It comes down to 2n plus 2 or something, 2n squared plus 2. So, like, it comes to 2n runs, and each run takes n times, so it comes to polynomial, something like that. So yeah, that's 2n plus 1 maybe. Yeah, that's why the optimization is important. And to do that optimization, what would happen is these labels would also be duplicated with the same names. You will have the same problem. I mean, there's a way to fix it. What we could do is, like, as part of a cleanup pass, just go and make sure that all the labels have different names, and that maybe it works. Yeah, that maybe it works. I could look into that. I don't want to promise that it would work. I don't want to step into something that would break some other code somewhere, so I have to think about it carefully. But yeah, now I get why it is called memoization. This does look, yeah, yeah, it is memoization in the implementation. It remembers across runs, whatever we have seen before. Yeah, so we're going to continue the same approach. We're going to keep memoization on, we're going to duplicate the code, but the later the label inserter, we're going to make sure that it inserts labels to the proper one. And when I say proper, I mean to the branch that it belongs to, like to the branch that's in its execution sort of sub branch. Like I'm going to try to any paper for the linear techniques. It's part of the BuildIt paper. This whole implementation, how it runs, how the extraction, how the memorization, everything works, is part of the BuildIt paper, the first BuildIt paper. I can do this, and then yeah, if you go to this paper, the original BuildIt paper, we do talk about memoization here. So yeah, oh, hold up, let me stop sharing Zoom. Yeah, if you look at this, extracting loops. Yeah, here it is. With memz, without memz, we sort of have, yeah, 2 times iteration plus 1, and we have 2 power iterations minus 1 as the complexity. This shows how the extraction process. Sorry, it comes down to O and cube. I forgot my own paper. Yeah, it's the third O n cube comes from the fact the third n comes from the fact that comparing static tags also is linear in the amount of size of the program, so that's why it's O n cube. But anyway, so this is why we do memoization, and I can talk more about it, but you can also check the paper out. Yeah, so let's keep that. Let's try to make sure that when we insert labels, we insert labels such that every goto goes to the corresponding label. Which, and what I mean by corresponding here is, in the case of featured code, sorry, in case of unstructured code, we want to create a label at that copy of the statement which is in the same sort of is in the statement block that this goto belongs to, or its parents basically. Like, we don't want to jump to a different branch. Duplicates label when memorization lookup happens. Yeah, we could do that. If we are creating labels eagerly, then we could duplicate all the labels in the code that we are copying. So we have to do like a deep copy of the statements we are creating. And at that point, if a label is being copied, we copy it. I think it's fine. I think that could work. That would have to change the methodology, because I would have to insert labels while creating the code itself, which we don't do. There's a specific reason why we insert the labels afterwards. It's because, like I said, the code gets moved around sometimes, and we don't want that goto to be moved somewhere else. What remains invariant is the target we are jumping to. We don't want to jump to some statement that's moved around. So yeah, if we had labels, we could duplicate them. But the problem is the labels are inserted afterwards. So the fix we are going to do is we're going to insert duplicate labels. We're going to insert a loop, a different label for the each runs, and we're going to try to maintain the structured property for it. So the way it's currently implemented, let's actually go to should be in blocks. Yeah. So I'm going to bump down the font. You guys can still see this, right? The font is not, but yeah. So I talked about these three passes. So there's the label collector. Oh, sorry. Label collector, there's label creator, and there's label inserter. If you guys have worked with compilers before, I know some of you have. Compilers are usually implemented, like the optimizations are implemented as passes, analysis and transformations as implemented as passes. These passes, usually like LLVM sort of passes, are normally meant to run on basic blocks on the LLVM IR. BuildIt maintains an AST as an IR. It doesn't have a basic block IR. So all these passes are essentially visitors or rewriters. So what I've done here is I've implemented this pass of inserting labels in the right place and wiring them up correctly as three different passes. So the passes are very simple to implement. You first create a new class that inherits from your visitor class, and then you sort of overload the visit function for whatever statements you want to visit. So if you want to change the behavior for like what happens when I visit a goto statement, you create your own virtual function that says visit goto statement, and then when you run the pass, it will normally default run the normal sort of visitor pattern of going and visiting each node in the AST. But for this particular goto, it will for all gotos, it will invoke your function. So now you can overload the behavior of what happens when you visit a goto statement. That's called visitor patterns. It's a very common thing in compilers. Yeah, you can find a lot of material about it. But yeah, so we use visitor patterns for updating this. So there are three visitors. The first is the label collector. What this simply does is actually pretty simple. So it only has a single visitor, which is if I see a statement, if I see a goto statement, I'm going to collect its label. I'm gonna collected labels dot pushback temporary label. What is collected label? It's a vector of tags. So it goes and collects all the tags that there are possible jumps to. This is like the first step. We go and see, okay, what all targets need to be jumped to. And this, I think, should be exactly the same. This need not be updated. We first need to find all the statements. That is fine. The second thing is this label creator. This one goes and creates all the labels that we have to insert the jumps to. So labels, there are two things. There's a label statement, and then there's a label object. So this goes and creates the label objects first, and then there is the label inserter, which actually goes and inserts all those labels correctly. So let's look at the label creator. Actually, no, the label creator creates the statement and the label, and the label inserter goes and patches back all the go-to statements to go to their respective labels. That's what it does. So let's see. Label creator is well, probably where the bug is. So label creator has a single visitor, which is this statement block. So it goes through every statement block. For every statement block in the thing, it checks, it goes to all the statements in that statement block. It sees if the static tag, so we call static offset, but it's actually static tag. Static offset of that statement is one of the statements we are trying to jump to. So it checks if it is in this collected labels, like if it's in this set of labels that we have to jump to. If it is in one of those, then it creates a new label at that statement. So it creates a new label, it gives the label the proper static offset, it gives it a name, so it gives it a unique name, so it says label 0, and then increments the current counter of all the labels that we have assigned. It creates a new label statement, inserts the new label statements in the new statements. But here's what it does. It erases the collected statements from the set of statements that we're looking for. So it says, okay, now that I have created this label, I don't need to like uh, find it again. It's never going to appear again. In fact, if it appears again, something is wrong, right? Because each label should only appear once. This is first part of the problem. This is what is causing a go-to to not actually have a go-to target to not actually have a go-to. We want to insert a label at all the places where it could jump. So the first thing I'm going to do is make sure that it does not erase this. Like we're going to keep the set of the labels as it is, So that way, every possible statement that has that static tag, whenever it's visited, will have a label inserted on that. We'll have a new unique label inserted on that. And then there's a separate table that we maintain, which is offset to label. So we just created a new label, right? It also remembers where each of these static offsets, which label has it created corresponding to it. This is so that we can go and patch those in later. And then what it does is it just like this is the inserter part. And then finally, there's the label inserter, which says, okay, now that I have created all those labels and I have this offset to label mapping, which is creating, okay, which static offset needs to jump where. I'm going to visit all the go-to statements again. And for all the go-to statements, their label now is offset to label table of their current target that they have to jump to. So the first thing at a high level, we first go and identify all the jump targets, the statements that where we have to jump. Then we go and create labels on the first occurrence of that statement. This was happening because of this erase tag thing. And then later we go and patch back all the go-tos to go to those labels. This is how the whole process works. Now, I think the first problem is that we have erase tag, which means not all labels are inserted. So let's first comment this and see what happens to our buggy code. Does it at least get a label where we want it to have a label? Obviously, now it says this is unused, which is a problem. So now I don't want to use attribute, and I'm just going to comment this because it's just going to go out anyway. But for now, let's just comment this. Yeah, that label, that code was wrong. Okay, now if I run this, what do I get? Good, we are closer to solving the problem. Now we have a go-to label to a label to BBIR would allow you to make further optimization. Right now, it seems like you have a hard-coded IR for a handful of cases that you want to solve. Uh, the IR is gonna be like this no matter what because we want to generate code that looks similar to what we originally had. So AST IR is a design choice. The the implementations are heuristics on what we are trying to do, and it seems like yes, it is a handful of cases that we want to solve. The part that actually Vedant was working on is augmenting this IR with a basic block IR. So he has written some parsers that take this AST, convert it into a basic block kind of IR, but also keep the original AST around. And then what it does is it uses the basic block IR to create loops like loop info basically, and then put that loop info back into the AST and create loops out of it. So it's a more sort of robust and a more methodical way of extracting loops. It does like a full dependence analysis, not a dependence, sorry, it does a what's it called, the dominator analysis and creates all the dominator trees and then creates loops out of it. So that is a better way that we are in like inserting into the code base. Currently, it extract loops using a bunch of like heuristics, which are not, I don't want to say they're tailored to the applications that we look at. They're more tailored at our technique of how we extract because we can only extract a certain kinds of flavors of the loop that we generate. Those heuristics cover that. It's not bad. I'm not completely unhappy with what we have as an implementation. I think it could be better. I think we need a IR1 to also be able to do other analysis. Like once we have that augmenting of the BBIR, now you can do a lot more analysis on the code before code generation. And I want to have that, but I want to keep the AST around. So it's like a very weird. It's a new thing actually. Having a AST with a basic block IR, augmenting it so you can use the basic block IR to make modifications to the AST. And every time the AST is updated, you can create a new basic block view sort of it. So that's what we are trying to go for here. But yeah, this is okay. The first sort of fix we did is we made sure that every possible target that we can jump at now has a label, right? This is important. Now let's see if this is correct. So this label 2 is now jumping to its label, but this is a problem. This is now jumping to its own, like this is now jumping to label 2, which is out of its loop. This is because what we maintain is this single offset to label table, right? We are maintaining a single offset to label table, which means we don't actually remember all the possible ones. In fact, I could change this to maintain all of them, but that would not be correct because if even if I would still have to decide which one to jump to, and that comes from the structure of the program. That doesn't come from like I cannot list out which goto needs to go where. It comes from which is a label in your parent block, at least statement parent block. And that's why this approach doesn't work correctly. Like go to label of equals new label. Even if I maintain multiple like tables, it won't work. So this maintaining single sort of table for static tags to label objects is a bad approach. I need to fix this. So how do we fix this? This actually is pretty simple. What I'm going to do is I'm going to comment this out from here. We don't need an offset to label table anymore. So let's see. This goes in label insert, right? Yeah, label creator doesn't need to have a offset to label table anymore. What we're going to do is we're going to create this table on the fly. As we are trying to insert gotos, as we're going to try to patch gotos, we're going to see if we find gotos like labels along the way, and we're going to build this map as we go down. And as we exit out of a statement block, then we are going to remove that from the table. That way, we always have a reference to the current statement block that we are at, and the label which is in your parent path. And that will sort of hopefully solve this. So I'm going to remove this offset to label. Uh, Hopefully, know where it's being used inside this. That is right. It's only being used in the other path. So I'm going to also, actually, this needs to have offset to label path one because it needs to have the current sort of mapping that we are holding, right? Because we have this like uh, sorry, because we still need to maintain a map, but that's like the current map, like which basic block we are in, or which AST statement block we are in. So we're gonna keep this. We're gonna keep this. But what we're also going to do is we're going to visit all the labels. We're gonna say, I don't want to just uh, visit the go-tos. I also want to visit all the labels. That's the first thing we're gonna do. And the second thing we're gonna do is we're going to maintain this parent information, which means I'm going to say you know what? Actually, we don't need this. We can skip over it. So we're just going to visit all the statement blocks. Okay, we're going to visit all the statement blocks uh, that in the program. So every single sort of nest, like if then branch, else branch, while loop branch, all those are like while loop body. They're all statement blocks. Right? So we're going to visit all of them, just like we had done that with the label insert creator before. So, and what we're going to do is we're going to maintain this map on the fly. So that's here's how it goes. We're going to write a new visitor function inside this label inserter. So let's say label inserter fit statement block PTR. By the way, these statement block PTRs are shared pointers, which is important because we have references all over the place. These are not like actual statement blocks. These are like pointers to them. And the benefit of this is we can actually share things across the things like we have these labels, right? The labels need to be uniquely the same. But having it as a shared pointer basically means that now you can also don't have to do the cleaning up yourself. And because this program internally maintains like an AST, which inherently means there are no cycles, so it never has a problem of like leaks or anything like that. And they obviously shared pointers have overheads, but this is part of the compiler, and this is not the actual high performance code that we are running. It's the high performance. It's the code that's generating the high performance code. So it's okay even if it is slow, and that's why we're okay with using share pointers here. If you use like, if you have seen any LLVM code before, they don't use share pointers for most things. Like IR objects and everything are manually memory managed. And I think for them it's okay. What LLVM does is basically creates new instructions as it goes, and then as part of dead code elimination, they are eliminated. So there's a single site where they can be cleaned. We don't have that invariant. We have a policy where you can create new nodes, you can remove new nodes when you want, and that's why we don't actually want to get into the business of manually managing our memory. This is very Again, this is because it's not motivated by performance. The motivation is by ease of implementation for the end user, for who is trying to extend. So yeah, all the AST data types are managed using shared pointers in this, and we are not worried about freeze about leaks because we have an AST. We don't have loops around it. So, okay, yeah, let's see. We have a label inserter that needs to go through all the statements. We are not going to modify this AST, so we're just going to iterate through the statements. But before we iterate through the statements, we are now entering a new scope. What this means is once we exit the scope, we would have to restore the offset table to what it was before, right? We would have to update. Actually, we want to do that. No, you know what? We don't need to. Every time we see a statement, okay, so the assumption is that every time a go-to statement is seen, the label that it's going to jump to would be before the the target that it has to jump to. So maybe it's fine. Visit we just visit. Let's try this. Let's see how this goes. Let's void visit label statement ptr. I'm gonna comment this one out for now. Let's see how this goes. Maybe there are some issues with this, but we can fix this. So as we go, if we see a label statement, what I'm going to do is the offset to label table of a of, am I assigning static table? Yeah. No, I'm not actually assigning it a statement. So I'm going to do a of label one of static offset. Yeah. Dot stringify. The stringify function just converts a label into a string form, so you can use it with maps. It's just easier. Deterministic destruction guaranteed with shared pointer. It's good, but LLM doesn't do that because it has deep inheritance hierarchies. Yeah, that's also a problem. In my opinion, LLM inheritance hierarchies are just too deep. Uh, I am not a big fan of that, but it's a design choice, I think. It gives you cleaner interface. Again, LLM is a bigger project than BuildIt, so I trust their sort of design decisions more than I trust myself. Uh, yeah, okay. So offset to label of a of label of. So whenever we see a new label, we're going to record the label item, the object. So this is a simple patch. All it's doing is offset the label of whatever that label is. I'm going to update the table to point to this new one now. This way, when I'm visiting, these visits are top bottom, right? We are recursively visiting the whole AST. So whenever we go through a statement block, if it sees a new statement, it's going to update the table. So anyone who is sort of coming up after that label in that path is going to see this one. And then when I go to a different branch, it's going to be updated again, and it's going to see a different label. So that way I won't have like these mismatching labels, which is good. Now that we have this problem sort of, okay, the other thing that needs to be done is this gets invoked from builder context. Yeah. I just need to make sure that the first one doesn't, yeah. So yeah, what we do is in the creator, we collect the labels, and then yeah, this offset table is sort of shared with with the inserters. This doesn't need to happen anymore. Like we don't need to give it the offset table we had created before because we haven't created that before. We start from a fresh one. Okay, actually, let's see what this does to our thing. It's gonna break a lot of other test cases, but we will fix that as actually it might not break other test cases, but this is not the complete solution. Okay, obviously it broke. What does it say? Oh, simple typo. Mr. Double colon. All right. Okay, let's look at what sample 50 produces now. Okay, so we have label 1 jumping to label 1, and we have label 2 jumping to label 2. So that at least solves this particular problem. We have enabled trimming from batch. Let's just quickly, momentarily also enable the rest of the loop passes and see if it solves the problem. There's obviously other things that's going to break, but we will fix that. Yeah, it should be fine. So what we do right now? We just like updated the table every time we go. So we're creating different labels for all the labeled jump targets, and then we are getting them. There is an issue with this, and that sometimes you end up creating unnecessary labels because you might have labels that are not jumped to. So we're gonna clean that up. We're gonna make sure that we don't have like bad labels lying around. Uh, and there we go. This looks like what we wanted. We have a while one outside, and then let's pull up our statement. Actually, yeah. So we have our while one on the outside. Then we have a if var zero is not equals to one, which remains as if var zero not equals to one. But that's actually okay because when you have a while loop inside a while loop, and the outer while loop is a while one, the inner while loop has a condition, you can collapse those while loops. This is not wrong code. What's essentially happening is if this while loop uh, now becomes part of this while loop, like this outer while loop, it just says, okay, if whenever this while loop runs, it goes to this true thing, and if this else branch is taken, which is what happens here, it goes back to the execution because there's a while one, and that's what is happening here anyway. So this is fine. This is producing. It's going back to the execution of the while loop again. If the while loop breaks, then it goes here, which is happening here, and then it goes to the end, which goes back again. So yeah, it is what we wanted anyway. So having a while one and a while condition loop inside it, the inner one doesn't have to be a loop. It just can be a condition, and it gets the same behavior. This is one of the benefits of like how BuildIt does thing. It's not like syntactically copying your loops from the existing code. It's recreating a control flow out of what operate sequence of operations it sees. Uh, yeah. So this other while loop that we had before is now sort of we previously did not get it correctly, and that's because those loop labels were not matching correctly. Don't get me wrong; those loop labels are not created like it's not a very hard-coded pattern matching in that if you have a if with a label before it, make it into a loop. It's a proper analysis. It does a bunch of things before it figures out where the loop needs to go, but it still makes an assumption that your loops and your loop targets, jumps and jump targets are structured, and only then it works like on those loops. Because at that point, if you don't have feature unstructured, it would only have structured loops. That's the assumption, and we have sort of made sure that that assumption is true right now. Let's see what happens. Let's just make sure that all our test cases run. Um, Okay, fifth sample field doesn't have an output, so it's still failing because I don't have a reference output. So at least everything else is working. But there's a case where this is actually a problem. Uh, Actually, let's see. So what BuildIt has is something called a like a more aggressive optimization called what's it? A feature unstructured. Let me actually show you that. Yeah, so when you're creating your context object, you can enable feature unstructured, which is defined here. It's by default false. What feature unstructured does is if you remember what happens when there's a memoization optimization, right? Like when we have a memoization caught, you can do two things. One is you can copy all the statements from the previous one, or you can create a go-to statement. So what this one does is instead of copying over all the statements, it just inserts a go-to to that label, which is like somewhere else in the execution. And what this does for us is you can never like you'll never duplicate any code in this case because this is literally the only part where code is copied over from other executions. if we never do this, we just insert a goto, what this ends up doing is it actually creates a goto to that execution rather than having to copy over the statements. This has its own benefits. Like you can now actually create control flow that you couldn't do in a control in a structured format. And also without, I mean, if you actually do, okay, let me actually draw it. You know what? This is harder to talk about in abstract, but I think we're also closing to the end. I can clean this up a little bit more, but I think this is more important. I'm talking about why control flow deduplication is bad sometimes is an issue, and why unstructured is required. So let's see. I'm sure you guys have seen examples before of unstructured code that cannot be converted into unstructured, like basic blocks basically, which cannot be converted into structured control flow. But let's look at a more concrete example. Okay, so normally when you have, you guys can see my whiteboard, right? So yeah, okay. So normally when you have a control flow like this is what we call a structured control flow. Something like this. This is structured because I can convert this into if conditions and loops and so on. But what happens if you have a control flow? This is basic blocks, by the way, like this. Never mind. Something that goes like this, and then that goes like this. Yeah, if you stare at this code enough, you will realize that this cannot be converted into an if condition. This particular thing, it's all forward. There's no loops, by the way. It's all forward. All these edges are forward, but you cannot convert this into a loop. This is a kind of an example of something that cannot be converted into if conditions because you can make this into an if, but then there's a thing that's going from the middle of the if to the outside. This cannot be expressed. So one way to make this into a structured thing is you can duplicate this part of the code. So or this part of the code. So what you can do is, sorry, let me undo that. Yeah. So what you can do to make this structured is you can keep the first block like this. You can keep the second block like this, uh, and then the third block. But this one that it jumps to is actually duplicated, right? And then here you have this. So let's label them. So like say this is B1, B2, B3, B4, B5. So here it's B1, B2, then it's jumping to B5. This is jumping to B3, B4. This is again B3, B4, and B5. Actually, B5 could be merged. Sorry, you don't need to have this here. So this could go here. Yeah. So what? Let me just clean this up. Yeah. So what you can do is this. So this is like now it is structured. Now you have a bunch of nested if conditions that like this is a if, this is a else, this is a if, and this is a else. What we did here is by duplicating uh, these set of basic blocks, we actually managed to make this into a control nested control flow. And this is essentially what BuildIt does too. If it sees something like this, by default it's gonna duplicate, which means it maintains the invariant, and then it can get nicer code out of it. But sometimes we don't want that. Sometimes we want it to actually have a jump in the middle because if you think about this, this is suppose this is in a recursive way, like there's an if condition and an if condition. You end up duplicating so much code that you have like the same code plastered over like 100 times, and we have seen that happen with like a regular expression code generator because regular expression is sort of a state machine that jumps in a lot of places. If you try to create structured flow out of it, it duplicates too much code. We have seen like files with millions of lines of code being produced from like a simple program, all because of from duplication. Sometimes we just want to say, I don't care about the structure. I just want a code that runs and does this behavior. So in that case, we have this feature called feature unstructured. That's basically what we enable here. So uh, if it's enable, all it does is it inserts a goto back again. What this also means is that you shouldn't run your loop finder. Like if you have it turned on, you should not turn like the loop finder on. Otherwise, you will try to extract loops out of unstructured loops. The invariant fails and everything craps up from there again. So yeah, we disable all the optimizations that are like the syntactical optimizations if the unstructured code is enabled. So there's a problem here. The way we are doing this thing, it assumes that you're always going to visit a branch before it's uh, the go-to it's jumping from. This might not be true if feature unstructured is enabled, right? If you have feature unstructured, it could happen that the go-to comes before the label, in which case we will basically do a invalid access to the table and everything will fail. So what we want to do is we actually want to have a backup table. So specifically in case of a featured unstructured, we're also going to collect those labels initially that we had created. Like we want some label, we want at least one label that we can jump to if it's unstructured. So that's what we're going to augment our like last change with to make sure that the that pass isn't broken. So what I'm going to do is I'm going to go back to our label inserter pass, and I'm going to keep this offset table that we had, but I'm going to call it like unstructured or yeah offset to label table or actually, for this one, it can be offset to label table, and this is going to be populated. So it's going to have at least one statement that because okay, this whole pass runs before we even start inserting labels. So as long as a goto has a target, it's going to be there here. We're going to have one target of this goto going here. So this way we can keep track of who we are jumping to. Uh, and then what I'm going to do is I'm going to go to label inserter, and inside this I'm going to have another offset table, which I'm going to call the, how did that happen? I'm going to call it the backup offset table or, yeah, backup offset to label table. And this one I'm going to only use if structured feature unstructured is used. So let's see. In the insertion mode, I'm going to say if I'm going to have to tell it that this is feature unstructured or not. So label inserter needs to know if it is feature unstructured, I'm just going to use the default one, like the one that's in the backup. So I'm going to say there's no difference here really because it will be unique in some way. There won't be any, but I don't want to risk like I don't want like long code that will check if it is there in the other table or not. So let's just do this. So if featured unstructured is enabled, then we have the label to jump to, which we must have seen before because it's on a different pass altogether. And then what I'm going to do in builder context is in the label inserter, I'm going to give it the backup offset table, and I'm going to also say inserter dot feature unstructured equals. This is a context. The feature unstructured is a context variable flag, so I'm going to say feature unstructured. Yeah, so I'm going to copy over the flag from whatever the context is. If the context says it's unstructured, then it's unstructured. If it's not, then not. And then that way I have a backup option to always jump to in case I don't find anything. And this doesn't need to be erased anymore. I'm going to remove this. And we're going to also remove this unused function. It's just clearing that vector. And yeah, let's see if this runs correct actually. I should probably have a test case that tests this weird feature of like jumping to a branch that you have not seen. Usually it ends up that you jump to a branch that you have seen, but I can create a case. So what happens is usually the true part runs first, and then the false part runs, and the true part also is printed before the false part, which means you're also like you're iterating through the like the true part first and then the false part. So uh, it never happens that you have a jump from the true path to the false path. Yeah, you usually have jumps from the else path to the true path, so it works out fine. But I think we need to have this as a thing for future memory. Okay, so with this, build it sample 50 produces reasonably correct code. I don't think this is wrong. And our test cases are working fine too. There's one more thing I need to do, which is now that we created these extra labels, if a particular label is not used or jumped to, we should clean it up. That's important because we don't want to have um, labels lying around in the generated code. Usually, the loop cleanup pass cleans up labels that it completely gets rid of using like loop analysis. But if it has something lying around, it won't clean it up. So, I mean, one way to fix this is to just have a counter on the on the label statement itself, and every time we point to a particular label or have a counter on the label itself, and if a particular label is never used, we just clean it up. So, but that's fine. I don't think we need that right now. I can do that later. I just want to like make this end to end, run the CI, and merge everything into the. Oops, mistake. Did something wrong. Reclaim me. How do I remove this? Does anyone know? Uh, this should not. Okay, yeah, perfect. Uh, you need to create a test case for it, properly cleaned up test case, and then create a sample output for it so it knows what to expect, uh, and then push it to the CI. Yeah, these samples have saved me so many times because I make some mistakes in like later code that I haven't seen a year ago, and then something breaks, and then I know that okay, I did something wrong. Okay, so what I'm gonna do now is sample 50 is reasonably okay. I'm gonna put it into samples output sample 50. It's like a reference output. This runs, and then we also need to run the same for like I have CI separately for with variable names and without variable names. So I'm gonna change the configuration file to say also recover variable names and test that if that was correctly too. This one obviously runs slower because it's compiled with debug symbols, and it also like does the job of extracting the variables as it goes. So you can see that the variables names are extracted to puts.var name sample 50. Now we have a sample for reference output for 50. And everything runs. So now I'm gonna do oh, actually we never cleaned up sample 50 properly. This nonsense shouldn't be here. Should be indented. We don't want it no test. We want it to be tested. Okay, now I'm gonna do. Let's see what is. Wait, why do this? Okay, we have the correct changes. I'm just gonna do a git diff to make sure that we don't have any bad changes. This mostly looks. Oh yeah, select this comment. We don't want this to go into the code, so two comments actually. Okay, so I'm gonna four. It shouldn't be here, and then this is all necessary. Should have probably commented the code more. I'm gonna do that right now. So because I should remember my like for myself later why I did these things. Main table to hold static back to table and this table holds the length that is of the run statement. Backup table which has at least one label that we can jump to use. Fine. Target. There is a lot of like applications that use feature unstructured. I don't have a simple use case example test case for this. Case. Actually, oh, we made a mistake here. Well, glad we checked this. This should be inside else. Otherwise, it's gonna try to do this access regardless, and it's gonna fail if this doesn't exist. Glad we looked at this again. Device is the one that is in the parent. Okay, this should clarify things enough. What I'm gonna do is also, so we have so we also do make format usually just to run a client formatter. Everything indentation, everything is great. Cleans up my mistakes that I did. This looks good to me. Why is the empty new line at okay, false? This is line 361. It was between false AST. Okay, so now I'm gonna commit these changes, fix the implement, fix the bug with labels not being duplicated across branches. I'm gonna explain the issue and everything in the PR, not in the commit. Where do? Oh, I didn't do. Everything seems fine right now. There we go. And by the way, I'm working off a fork of BuildIt here. I don't work on the main branch. This is my own personal fork. So the CI will run here and then I will merge it with the main one. So let's do that. my own fork, which is here. Yeah, so you're gonna push it. This is my first stream. Gonna share it on my socials. Thank you so much. Yeah, I really appreciate you guys sticking around for till the end. By the way, and I hope you found this useful in any way. I think we don't talk about compilers internals enough. We should talk more about it. I think whenever someone says like programming, it's mostly web programming or games development. There are definitely a lot of good streams I have seen. Like one of the old PhD students from CSAIL, John, he does a lot of REST programming on the stream and it's really great. Uh, I really like wish that we can start this thing about like talking about compilers and row level systems. Yeah. Anyway, so let's wait for the CI to run. By the way, my CI is very simple. I used to have fancy CI before, but right now it's just GitHub Actions to run and compile the code and run the samples. Both the one with recover variable names and without like, variable names. But yeah, at some point I'll build something more. Do check out LSP though. Yes, you being a compilers guy might appreciate it. Lack of compiler engineers is the reason why we have too much UBs and faults with language design. Yes, I think the problem with that is, while we're doing this, let's just talk face to face. Yeah, the problem with compilers research is uh, it's inaccessible at this point. Like we don't teach enough compilers to undergrads internals development research at all, and it's hard to get into like this very weird um, dealing with program as a data kind of stuff. The optimization that we do, the analysis that we do are inherently like difficult than other stuff, and I think that's part of the reason why we don't have engineers. Obviously that means that we have bad language design, and I think we can fix it. The more smart people, I'm not saying people are not smart, it's just they're not taught this thing. The more smart people we have looking at these problems, the better solutions we will have. And I hope so. Like my a part of my thesis is making it possible for more people to write compilers in different ways, not using like compiler internals like through these abstractions, but getting more people interested into writing compilers. And Yeah, I think what was I going to get at? I was talking about something. Yeah, it also means that there's a plus side to it. The fact that there are fewer compiler developers means that the jobs for compilers are pretty like high paying in some way because finding good developers is takes a while. Like if you have been in the industry for like 6 to 7 years or whatever, you can make a very good income. Yeah, make more money. You can definitely make more money out of compilers if you are good at it. But yeah, takes someone to actually get into the internals and understand it. So hopefully my stream at least sort of motivates people to look at compilers, talk about internals. Yeah, Jane Street. I know. Jane Street is probably another reason why people might also look at compilers because high-paying jobs require some compiler expertise. No, I think the world is tending towards that. We have more and more high-performance applications, both from machine learning, from like all AI stuff, even the crypto stuff for bad reasons. But anyway.
Frequency trading stuff. I think that definitely is bringing more people to like, get interested into compilers, which is good. I think that's correct. Okay, I'm just gonna check if the CI is running still. It takes a while. It takes a few minutes. And it also tests on both Mac OS and Linux. I don't have a Mac OS version lying around, so it's easy to have CI which does that for me. So yeah. Yeah, right, CI folks. Don't skimp on making sure that your test cases are always running because then you'll be like 20 commits ahead and you'll eventually realize, oh hey, nothing works uh, because you broke something. I am planning to write more test cases about this particular bug that we fixed today, but I don't want to like take too much time on the stream, so I'll do it. And I'll share resources for all this, by the way. I talked about a lot of like papers, and I talked about like this PR also. I'll link it in the resource repository, and I'll put the resource repository on the channels about section, so you can check it out later. And we'll maintain one resource for all the sort of future streams too. So there's one place where you can find everything. Special hardware is hard. Yeah, CI for special hardware is hard, but you can test it in simulations. I think a lot of new hardware is. Oh, you mean like for like not for developing hardware, for using special hardware? Yeah. I mean, even writing CI for GPUs is hard these days because finding GPUs on the cloud for running CI is expensive. Uh, I have a GPU CI. So I used to work on a graphic project, right, which had a lot of GPU code generation and performance CI actually. That used to run on a local server. So I had written my own sort of a CI server that every time I have a PR or a push to the main branch on the GitHub Graphic repository, it used to run CI locally, and then it used to send me an email. So I still have like emails lying around from all the cron jobs that used to run. I don't run that anymore. I think Graphic is not under development at this point. Okay, we're gonna beat the shit out of all FPers in one go. Chain state has done some remarkable engineering. Yeah, OCaml is a good balance, I believe, between FP and high performance like C++ or whatever imperative languages. I have seen some software that's pretty good. I personally don't use OCaml. Oh, by the way, OCaml also has a meta OCaml, so that is pretty close to what I do too. I have actually taken a lot of applications from Meta OCaml to redo with BuildIt. Yeah, I just feel like the difference between Meta OCaml and yes, I will check CPP front. Yes, I'm gonna open this right now so I have it. Don't forget it. Yeah, and LSP too. Yeah, the reason I think BuildIt and OCaml differ in a way is I think C++'s syntax and the BuildIt syntax at least is more natural and closer to C++ syntax for writing high performance code, and the people who are coming in, they have a lot of expertise in writing C++ code. So high performance, even like parallelization, they use OpenMP, they use all sort of parallelization, vectorization even. It nicely marries into BuildIt syntax. BuildIt is, I mean, eventually C++ library. It's not a special compiler or anything. You can run it with like a normal G++ or Clang++. So I think MetaOCaml has advantages. I think we also have some advantages which are in a different direction. Uh, the other benefit is syntax, like going between two stages. Okay, oh, MetaOCaml, you would have to I'm not sure what the difference, like, is it a separate language or it's like just a meta part of OCaml that they call meta OCaml. But when you have to like go between stages, you would have to rewrite a lot of code because you have to write it in a coded form. In BuildIt, everything is the same, like all the syntax for all the stages is the same. You write normal loops, you write normal conditions. You don't actually write a special construct for it. All you have is these types, and if you use templates enough to sort of abstract over these types, you can change the type in one place, and everything would sort of change, like produce very different code. So I like that aspect of BuildIt. OCaml itself is a meta line. Let's see. CPP front I'm definitely gonna check out. A personal experimental C++ syntax to the syntax one compiler. I see. There has been a lot of like extensions to C++ syntax projects. I don't know if you guys have heard about Circle, which is another like really good project. And recently, I think they were working on insert like lifetimes and like Rust like borrow checker into Circle, uh, which is interesting. I don't use borrow checkers, but yeah, I mean I don't believe in borrow checkers as a so solution for the lifetime problem, but people who like it use it. Okay, CI is still running. Oh wait, yeah, finished. So let's go back to us. It's out of the way. Okay, yeah. So yeah, CI has completed. So we have Ubuntu actions running completed. So we have the normal make run, which said everything ran correctly, and we have recover names also run correctly, and then we have the same on macOS also run correctly. The macOS one doesn't run the recover one because it doesn't have that debug symbols. It has different debug symbols, and I don't want to implement the recording variable names from macOS debug. So yeah, that's not going to happen anytime soon. So yeah, test cases are running. Sorry, have finished. So what we're going to do is we are now going to create a PR. And here we're going to explain stuff first. So fixes this one, fixes 53 from the original one. Yeah, that's like the heading, and then say okay, yeah, back in the reference issue, and issue jumps and jump targets being duplicated, branches due to I like to call this failure to merge, where we cannot really, like, even if the statement is the same, it cannot be merged for whatever other reasons. Uh, this causes the jump to target the label that is in a different branch, messing up the viewfinder invariant. We fix this by inserting labels at all possible jump targets for a particular static label. Maintain the current label if statement block. Update it has been added to the thing. Cool. I'm gonna create a pull request. I'm actually gonna merge this immediately because I know it's gonna merge. I don't need to open for the CI again. The two folks are in sync, so it's gonna merge it. Won't take too much time. Yeah, but the thing I should forget to not forget to do is actually go back and sync those folks. So the next time this happens, I have synced folks, and then I will just take it. There we go. We have our changes merged. And that's the bug fix for today. I was hoping to have a more sort of like bigger bug to approach, but I think this is the first stream, and I had to give a lot of context into how BuildIt works and stuff like that. So I think we started with a very simple bug. In the future, we'll do more complex stuff. Hopefully, you guys would enjoy that too. Okay, so then I'm going to end the stream here today. I am going to let me put myself back on the screen for a minute. Yeah, thanks a lot for attending. Okay, let's see. There's some comments I missed. Talk about why don't you like the borrow checker the next stream? Yeah, I would love to get into that. Although I don't want to make this into an anti-Rust stream in any way. I don't think this is the intention of the stream. It's more about like talking about C++ and not about talking about C++ in the sense that I'm teaching C++. I'm sure you guys definitely know better C++ than I do. It's more about approaching some of the problems in C++ from a research angle, from an academic's point of view on how you use these languages. So yeah, I think I like to keep it like less about Rust or any of the borrow checkers, but yeah, I can talk shortly about it. Tara, why don't you like Chikaria? Circle is out of frustration with the C community, so Sean is writing a new language as a result of that. Yes, I think that's good. I think having more languages with similar features is good because C++ has a lot of non-technical problems too, like just like the whole I guess I mean I don't know I don't know too much about it, but I've heard a lot of like issues with how features are added, and because of a lot of backward compatibility stuff, things get messed up and they sort of become this weird mess. If we start from a new language which has all the niceness of C++ and there's no sort of backward compatibility reasons, we can make more cleaner abstractions. Yeah, pro C++ to anti-res. Yeah, to pro C++ is better than anti-res. Yeah, I think that's the stance I'm going to take. It's too much negativity. Anyway, yeah, thanks a lot for attending. I think the stream went longer than I had anticipated. For the next time, I'll plan for a longer stream. I thought 2 hours would be enough, but since you guys stuck around, I was happy to keep running it. So that's all for today. I think I'm gonna wrap up, and I'll post all the resources on the Twitch channel. Also post on Twitter if you follow me there. If you don't, the link at the bottom has it. But yeah, all right, sounds good, folks. I'll see you next time.